getting tired of trying, forgetting every word that I said in all those old conversations. Turn into a melody. I'll be waiting for autumn days ahead of me. Those words that put me under are never coming back again. I like my beat with some soul, I like my girl with some heart. I only love with my whole, I don't know how to give part. I don't know how we gon' finish, but I love how we done start. So let's take a night to just be who we are. So I ain't got the time or the energy, unless it's towards a goal or a memory, and to be doing things that I don't really love. Only light I had was coming from the sun, but now I'm shining on a cloudy day. And it don't matter what you say, cause even if the sky is falling, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here.
Every day I gotta light one, yeah. Never not that it a tight one, yeah. No, I keep it 100 every time I come in trouble. No, we coming with the right ones, yeah. 35 can't play, get a bag on ya. Never with the games, put a tag on ya. I ain't getting lit cause my future too bright. Joey hit me up, I said that's just on site. No, it's too nice. No ops, no lights, new heights that we never hit before, and I'm feeling too high. Gotta roll like a road on. Major difference is the platinum and the gold songs. Whoa, oh, you already know. I can make your life a push start, press go. Say we're off to a good start, let's smoke. Blew the brains off the coupe, baby, explode, yeah.
Shining on a cloudy day, and it don't matter what you say, cause even if the sky is falling, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here.
Hey, let's move to back. Let's do it. What are we doing? Let's try to go out. Well, everybody come out here real quick. Everybody come out. Come here. We're gonna sing together. Hey.
Shining on a cloudy day, and it don't matter what you say. Woo! Cause even if the world is ending, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here.
Slow, you smell like smoke. I know there are worse things than being alone.
Cause these days move slow, and I need some smoke. I know there are worse things than being alone.
But I'm far from home, and you seem so close. But my heart's still sore, and I know you're just feeling alone.
Cause I'm far from home, and you feel so close. And my heart's still sore, and with you I don't feel so alone.
You're tripping over every move I made tonight. So fall for me and I'll catch you, baby. Cause these nights move fast, and I hope this lasts. We can let time pass, but you know that I'm gone and I can't look back.
These nights go fast, just hope this lasts. We can let time pass, but I know that you're gone and you're not coming back.
It's blue and black, with you it's bad. It's like you knew that I had to have you.
I'm bruised and black, with you I'm bad. It's like I knew that I can't, but I had to have you. picture with a tan like, can't believe where I am. But who I'm with, think I'm falling. Think I'm falling. Take her to a house on the beach like I'm balling.
You're tripping over every move I make tonight. So fall for me and I'll catch you, baby.
This is casual slow. Smell like smoke. I know that worse is than being alone.
Please don't get jealous of the things I've done, 'cause I have made my way through the better days. I will not be angry if you walk away, 'cause it just proves that you are not okay. I should've known from the start that I was starting something. Ooh, ooh, ooh. I should've known right from the start that it would end in nothing. Ooh, ooh, ooh.
I can't help but feel the way I feel when I'm with you. When I'm with you, I can't help but feel the way I feel when I'm with you. When I'm with you.
Please stop your yelling, you used to be so calm. You were my number one, but now you're just no fun. I showed you my hand and you played it repeatedly. Oh, and now it's time to go back into me. Oh, I should've known from the start that I was doing something. I should've known right from the start that it would end in nothing.
I can't help but feel the way I feel when I'm with you. When I'm with you, I can't help but feel the way I feel when I'm with you. When I'm with you.
To be honest, I don't have the words for this feeling. I feel alive every time we in my house just chilling. These butterflies come to life and my head starts spinning. And I crash every time that you say you're leaving. You know there's nothing I'd rather do than walk down the road and chill with you. Whenever I'm gone a while, I can't help but miss your smile and wish that I was back home. No, I wish that I was still home with you.
we both get a little bit homesick. And I know you're in bed feeling worse than ever. Because it just don't feel like home, and that's we're together. You know there's nothing I'd rather do than walk down the road and chill with you. Whenever I'm gone a while, I can't help but miss your smile and wish that I was back home. I wish that I was still home with you.
Hey there, my name is Jen Cole. I'm here to give you an update on all things DevFest 2020. This year, Google developer groups are coming together in a whole new way, virtually over one weekend. Now more than ever, we yearn for community. This global movement empowers you, the developer community, to teach, learn, and connect when you may need it the most, from the comfort of your own home. What can you look forward to this year? Technical talks, a keynote by Google developers, breakout sessions, and so much more. These sessions will cover a variety of technologies. The magic of DevFest has always come from the people involved, developers from all different backgrounds and skill levels who come together to learn from each other. Sign up today.
All right. Hello, everybody. Welcome to DevFest Alberta. My name is Greg Bennett. I am the founder of GDGYYC. We're joined today from by DevFest, or sorry, not DevFest, but GDG Cloud Edmonton as well. And we have a great lineup here for you today. We have a bunch of speakers from around North America and actually around the world. So given that everything is virtual, we'll work on making sure that all of it comes through okay. So yeah, so this is stream one. There are a couple of different streams here today. We've got stream one, which is sort of the live stream. We'll be looking for your questions on YouTube. And so you can go to go.devfestab.com/livestream. So I think you're here already if you're here. And then second of all, you can also go to the Experts Lounge, which you can find at go.devfestab.com/experts. And we'll have stuff going on throughout the day. You can check the website at devfestab.com/schedule to see the schedule. So yeah, so I just wanted to say thank you so much for joining us today. I know it is Saturday for most people, and thank you for taking the time today to show up. We've got a really great lineup. So let me just check in really briefly. We are working through a couple of issues, and I just want to make sure that we're ready to go with our speaker. And just give me 1 second, I'll be right back.
So 1 second. So you can see my screen. All right.
All right, so coming up this morning, first up is going to be Kyle Paul. So welcome, Kyle. I think we're on together, and yeah, let's just, I just want to have, I actually had a couple questions for you before we get started with your presentation.
Awesome, let's go ahead and kick it off.
Yeah, absolutely. So first of all, I wanted to ask, where do you live right now? And yeah.
Oh, so traditionally I'm based out of Sunnyvale, California, but currently I'm back at home in Kansas City, Kansas, kind of hiding out from COVID since we're allowed to, be at work from home, and I still happen to own my house. So there's always been that joke since I travel so much. I still owned my house in Kansas City. I have a place in California, and then Canada is my third home. So it's great to be virtually back in Canada, speaking to everyone. I wish I could be there. I was there last year in Calgary. It was so much fun. I need to make it up to Edmonton, so to see all the folks up there. But fingers crossed for next year or sometime again in the future.
Yeah,
soon.
absolutely. Yeah, no, we're looking forward to 2021. Hopefully we can get this stuff sorted out. And but yeah, thanks for joining us. And again, thanks for joining us last year. We did have a great time last year at DevFest YYC. I wanted to ask you a little bit about your presentation. I know that this is a new presentation for you. So I wanted to know a little bit about how it came to be and what sort of got you excited about the topic.
Oh, of course. So today I'll be talking a little bit about Google Cloud IoT Core and how I first got interested in Cloud IoT Core is, so prior to joining Google, and I'll probably do a little bit of deeper dive on this during the talk, but prior to joining Google, I was a part of a startup, and I was a co-founder for a startup, worked on a bunch of different fun initiatives, and this one idea came up to us about building these little IoT trackers for these refrigerated vehicles, and it didn't really take off here in the U.S., but it really took off over in Europe, and so working on this product, working on like integrating IoT in the cloud. That was kind of my first true dive into IoT. I've done things with Raspberry Pi. I've done things with just kind of hacking on hardware, but this was kind of my first foray into like, how do I need to build something that can be managed remotely? So, because like when you're dealing with the Raspberry Pi, you can like, oh, it's broken. You bring it back home, plug it in. Or if you're toying around with IoT around the house, I was like, oh, I can just reset it, plug it back in. Well, I had to develop a solution for these IoT devices that were deployed out countries away, hundreds of thousands of miles, that were I could either reset them remotely, push out firmware without having to have the device at my desk in order to do all this stuff. And so that's where I found Cloud IoT Core. At the time, it was still in alpha, and so got to mess around. And it was working really well for an alpha, and they've added a lot more features since then. But that's kind of what really got me interested, and I've always wanted to dive back in a little bit more. since that project. And so that's kind of where I wanted to learn a little bit more about what's been happening with Cloud IoT Core since then, and how, in talking with Greg, IoT is something that has come up recently in Canada as something of interest. So I was like, hey, this is a great time. Let's put this together and see how it goes.
Yeah, absolutely. And it's funny, IoT Core came out, what was it, a few years back now. I think the company I was working at, we had alpha access to it and built a little bit of couple of widgets to control some oil and gas related stuff. But of course, in Alberta, given the nature of Alberta and industrial applications for IoT is insane. It's actually insane how much we could utilize that. So yeah, really excited to hear what you have to share, and looking forward to learning a little bit more about building data pipelines with Google Cloud IoT Core, which I love that it fits perfectly with our theme of building the pipelines of the future. So
Awesome.
thanks for joining us, Kyle. So I'll let you take it away, and then once you're all done, I'll jump back in for a second, and we'll make sure if there's any questions, I'll ping you with them.
Oh, perfect. Yeah. Yeah, I'm more than happy to take any questions you have about anything in my presentation. If I don't happen to have the answer right away, I will make sure to get it back to you. And then to preface, I do have a session later today on Google Developer Expert, which I'll touch on a little bit in this talk as well. So.
Oh, and I do need to make one quick mention, and that is that Stream 2 is live as well. And so you can go and right now you can hear from Neil Kurit on monoliths to microservices, the journey to cloud native. And that is at go.devfestab.com/experts. So again, it's go.devfestab.com/experts. So if that's a topic that you're interested in, you can also go and take a look at Neil. Of course, because it is virtual, you can also do both at the same time. So feel free to do that. Okay.
I assume it's recorded as well, correct?
It is recorded, yeah. This one will be recorded, and I believe the other one will be recorded as well.
Awesome.
All right, thanks, Kyle. Take it away.
Perfect. All right. So thanks for sticking around if you're still on my stream. If not, catch the recording. I am Kyle Paul. I am the North America Regional Lead for Developer Ecosystems at Google. And so what that means is I'm part of a team at Google that I'm not for a specific product. I'm for all products at Google, and particularly for the community. And so this is groups like GDG, GDE, DSC, Women Tech Makers. So we have all of these various products, and so I look after primarily GDE and DSC. And so I'll tap on those a little bit, but one thing that no presentation is without, any guesses? Of course, it's cats. So you need to have cats in a presentation. So these are my two little cats, Penny and Jules, one of the very few photos where they're snuggling up with each other. They love to horse around and whatnot, but you just have to throw in cats in a presentation. So thank you for humoring me. As mentioned, we have a bunch of different programs around North America. As Google Developer Groups, Women Tech Makers, Google Developer Experts. We do have this recently launched earlier this year in Canada, the Accelerator Program, which helps startups get up off the ground and help them through some different accelerators. And then we have our Developer Student Clubs, which launched first in Canada in 2018. And then we launched it right after that in the US. So two things that launched first in Canada before the US. So I know that hopefully makes a lot of you very happy there. But yeah, so to look at our agenda, what I hope to cover and I'm really looking forward to a lot of questions around this because as Greg mentioned earlier, this is a brand new presentation. All of you are the first to get to see this. And so what I hope to learn from all of you is what more you would like to see and learn about IoT. This was just basically me putting together a bunch of stuff from my knowledge set, some stuff I looked at online when I was researching this that I thought was really cool and I wanted to share. So from this, please ask a lot of questions. I would love to hear your feedback on this as well, what you would like to see in the future. But so essentially what we're going to be looking at is what's the future outlook for IoT. We hear a lot of things about IoT, but where is it really going? What do we project will happen? And then I'm going to do a little look at to what is Cloud IoT Core, cover some of the basic features, why you would choose Google's Cloud IoT Core over other services. And then so most of you are likely familiar with HTTP, and you've probably heard of HTTPS. So because of all the TLS and security things that have gone on the web. But many of you might not be as familiar with MQTT. So we'll look at that a little bit and then wrap up with one of my favorite toolkits for that I liked a lot when it helped me kind of really dive in to understand what Cloud IoT Core did, some functionalities, what I was capable to do with Cloud IoT Core. And I'll share some examples that, just toying around that I found. And so to go ahead and kick off then, so for the future of IoT, if you look at Gartner, who they do a lot of reporting for the tech industry and projections and scaling and stuff like that. So they project by next year, there'll be 25 billion IoT devices in service, and which is an astounding amount. And where a lot of that comes from, and that number likely might have changed after this year. A lot of companies, because of COVID-19, started to adopt IoT services where it was using camera features to where it was scanning, making sure people are wearing their face masks in certain workplaces like healthcare, or they're, because of the social distancing implemented at warehousing and retail facilities, they needed to implement different IoT solutions to help augment the reduced workforce that had to happen, unfortunately. And so there's a lot more devices that were put into play. So likely there was a large jump in this because of COVID-19 that happened. And so I would expect this number to be, a lot higher for next year. I'm not a soothsayer, so I won't make any predictions on what that number is, but I would predict it to be a lot higher for next year. But do look into Gartner if you are interested in following on in the tech industry and what where they do have a lot of interesting reports on where IoT is going. But so a lot of companies are investing in IoT. And there was a figure in one of the reports from Gartner that said over 60% of CEOs that implemented IoT in their companies had better than expected results. So, these are large enterprise companies that are implementing IoT, and they're finding that, this isn't as scary as, it's not a side project, it's not a hobby, it's actually something we can use to enhance and make our companies a lot more efficient. So when we're looking at, creating, more efficient pipelines, processes, all that fun stuff, pardon me, that's where, IoT really comes into play here. And the IoT, from the Fortune Business Insights report, they anticipated by 2026, the reach for, and this is in USD, is $1.1 trillion that's how much the industry is valued at. So that's just, astronomical on, thinking that, how much these companies are investing in IoT. So that gives you any indication that IoT is not really going away. It's not really a hobby side project thing that, you hear all of us developers are, I want to hack on this, I want to hack on that. A lot of these companies are definitely investing in this as a future for technology to improve their efficiencies in tech. And there we go. So with IoT in the cloud, this is where, let me scale that down a little bit. And this is particularly with Google Cloud IoT. And so IoT devices need a lot of storage. So the device itself might not have that much storage on board, but they produce a lot of telemetry. And so this is why you would choose the cloud over a local solution or trying to store all of this telemetry on device. They produce a lot of telemetry whether they're recording, temperature, GPS location, whatever sensors that you have connected to it produce a lot of telemetry. And so that's where you would want to reach out to a cloud solution to offload and store all of this telemetry. And IoT in the cloud can provide a greater space, which can increase as per your users' demand. So the more devices you have out there, obviously that's going to propagate out, and you're going to have a lot more storage need. So if you use a scalable solution like Google Cloud, it's definitely help you there. You'll also have the increased performance, where when you're connecting to the cloud, there's lots amounts of this data. They need that ability to keep sending the data without having these holdups or connectivity issues, where with the cloud, it's just going to be consuming, particularly with PubSub. That's what I would recommend with Google Cloud is you have the PubSub with the telemetry, you consume it and bring it in. And there's a lot of increased security when you choose cloud as well. I know there's been a lot of stories and you hear all of these reports about security issues with IoT devices. And if you look at a lot of these reports and not just the headlines, a lot of the security resides in like the routers, for example. So it's much closer to the device rather than where the device is connecting to. And so that's where, however you're developing your solution, is to check at what's going in between as well. So how these telemetry packets are being handed off and how your devices are connecting, whether it's via Wi-Fi or cell tower. And as you dive into IoT a little bit more, those are the two primary ways that you can connect. There is Bluetooth, there is other solutions to connect with your IoT devices. Primarily what you're going to use for remote, if you're distributing IoT devices out in the field, you're going to want to use something like Wi-Fi or cellular. And with Google Cloud IoT Core, it supports the standards MQTT and HTTP. So being that those are industry standards for IoT, if you already have an IoT solution, it's very minimal updates to your firmware in order to get it to connect to Cloud IoT Core. And as mentioned, it's scalable. So as few or as millions of devices that you have, you can disperse them and have them all connect through Cloud IoT Core in a horizontal scaling fashion with load balancing, smooth data ingestion under any conditions that you run into. The one thing that I really loved about using, love about using Cloud IoT Core is how it has that two-way communication between the IoT console and your device. So a lot of solutions out there are basically they'll just push to the device, and then you have to have a separate endpoint set up for collecting the telemetry. With Cloud IoT Core, it has a two-way communication with your device. So not only does it allow you to push out new firmware or new config, new settings, all this awesome stuff, you can also, it updates back to the console. You have that two-way communication responsive with how all that data pipeline works within Cloud IoT Core. So all your device updates, firmware, settings, all that. And then you're able to monitor how these devices are performing. So it's giving you feedback based on how the device is performing with what the connectivity status, how long it was disconnected for. And it also depends on how you write the code too. If the device you tell it to disconnect and only collect telemetry on board for a while, and then you write the code to say, hey, try to reconnect to Wi-Fi or cell, and then do my data dump in the cloud, and you can monitor a lot of this. So you're able to monitor your devices from Cloud IoT Core as well, which is really, really awesome. And so to take a quick look at HTTP versus MQTT. So I have two graphs here. Sorry if they're a little small. I don't know how things are looking on your end of the stream.
It looks good. Yeah, well, we're pushing those ones a little bit larger for you, so it should be you're small.
Okay, perfect.
The graphs should be a little bit larger.
I tried to make them as big as I could to fit on the screen, but with this, MQTT is, just to kind of sum this up. So there's a whole blog post that we did that summarizes this test that, it put MQTT and HTTP up against each other. And so in the graph here, you can kind of see, if you go to the blog post, you'll see the graphs in larger detail, and you're actually able to see all the milliseconds per message and telemetry information, like what was being sent in each package and all that. And so with this, MQTT, they're both handling the same data telemetry package, but you can see that MQTT is a lot faster. There's a lot more efficiency when using MQTT. There's also the built-in security, if you will, with MQTTs on how the telemetry is being passed through. So not only is it, you have the protobuf, which is an efficient way to serialize your structured data and send that telemetry through. Being that the standard is a lot more secure than just HTTP, whatever telemetry you have that's passing through, and this is where concerns come in. Let's say you happen to be in the healthcare industry, and we wouldn't necessarily want to try to build a solution that transfers PII in telemetry information. But in this, if it can be mapped back at any point, or how things are working, definitely I would choose MQTT just to keep everything on the safe side. And I was actually using MQTT on the solution that I developed for which launched in Europe, not as much here in North America. But yeah, so with MQTT, it kept that encryption secure, or that connection secure. The telemetry was easily set up between Cloud Core and the device. And it was a lot of just point and click with this too. But you get a lot more efficiency gains when using MQTTs, increase in information density for each payload. So that's the other advancement that you can get with MQTT, is the information density per payload. Obviously, what you can do is reduce the payload size, but with MQTT, it can take large dumps with the data. And I'm trying to remember, I think I was doing up to 3 meg dumps during the alpha, but obviously you probably want to chop that down a little bit whenever you're doing, depending on what your connectivity strength is, whatever your, and we scaled it back eventually, but I that was kind of like the largest dump I could do within the telemetry with a strong connection. So, and then so with that, on some tools and examples, there's many different toolkits. So if you're on the Cloud IoT website, you scroll down, there's a lot of different kits that are recommended. The one that was my favorite, and so a little bit more background about me, I'm traditionally a web and cloud developer, not so much on the IoT and mobile app side. And so with my web background, there's a solution out there called Mongoose OS. And with Mongoose, it allows you to write in JavaScript for IoT. And so being that I had a strong JavaScript background, I was like, hey, this sounds like a great solution for me. And so there's a lot of connectors out there, a lot of tools out there. And so the ESP32 board, there's there's another couple boards out there, but the ESP32 Feather, there's the Huzzah, there's a handful more boards that Mongoose supports, but yeah, so on these devices, little tiny chip that you can add a ton of sensors to, and if you get the kit, it brings in a bunch of the different sensors. So like your temp sensor, I believe there's a camera included in that one, motion sensor, there's a light, buttons. So there's all kinds of different sensors you can play with to see how it all connects together. And if you're like me with a web background, you have a JavaScript at your side there. So JavaScript not only helps you in the web on mobile devices, in the cloud with Node.js, now it also helps you on IoT devices. So that definitely helped me a lot getting up to speed really fast with IoT. And what's really awesome is Mongoose OS is fully supported by Cloud IoT Core. And so it was very, very simple to configure and set up the device on Cloud IoT Core, where I was able to manage multiple devices at a time, push out firmware updates remotely, and receive the telemetry. And how I was receiving a lot of the telemetry was via PubSub and then consuming those into Firebase. So those of you who've seen me give talks before, it's generally around Firebase. And so so of course I had to drop Firebase in my talk. But so with Firebase, you consumed them with Cloud Functions. And what I did was, because when you're receiving these telemetry packets from your devices, they're kind of all over the place. So they're just text streams essentially. And so what I had to do was I capture those via PubSub with a Firebase Cloud Function, sanitize them, and then that way I could dump them into my real-time database, or I was using real-time database at the time, or you could use your Cloud Firestore database as well through Firebase. But and so that's how I was dumping the data in, was sanitizing it through Firebase Cloud Function, dropping it into a Firebase database, and then I was also able to build the Firebase dashboard that connected back to Cloud IoT Core to report on my devices in a nice dashboard. And then you can click on the device, see what telemetry was being reported by the device. If you use special libraries, you're able to do some graphing and whatnot. But then you can also, depending on how many devices you have, how much data you're consuming, there's always BigQuery as well. And that's one of the other big things that we advertise for the IoT community is you're going to be collecting a lot of data through your telemetry. And so that's where looping in BigQuery helps a lot to really analyze and look at your data. And then with Cloud IoT, there's also Cloud IoT Edge, which is what allows you to do machine learning on the device. So that way you can analyze locally on the device before it pushes that telemetry up. Now, I didn't want to include or dive into too much with Cloud IoT Edge because I haven't fully tested that one out myself. So I don't know how well it works with Mongoose OS. I didn't want to be like, yeah, go run for it. But that is another thing that we have available is Cloud IoT Edge, which allows you to do a lot of these machine learning decisions on your devices, and it's in a very small packet that you can run on your ESP32, for example. So that way you don't need a whole lot of storage space. You don't need the gigs of storage space on an IoT device out in the field. You can quickly make and analyze these decisions remotely. And with that, I know that felt really fast to me, but I know I wanted to thank Greg and the team for having me here, and hopefully we have a lot of questions so that way, because I have a lot more to share, but I'm trying to think of other fun things, examples that I've worked on, or how that worked.
I do have questions actually, Kyle, and I'd be happy to answer them. We actually had quite a few. And one of the things that I think is really interesting about Alberta is we have a fairly hardcore corporate culture. I mean, a lot of the hydrocarbon energy companies that exist in Alberta They operate they've operated the same way for a long time, and so there's a fairly well established culture, right? So one of the questions are Google's IoT, is the IoT core, is it able to fit within a corporate maintenance structure? And how do you have any insight on that and how that might sort of play out? So you build these things, you set them all up, and now you're trying to maintain them all. How does IoT core help that situation?
So if I'm understanding correctly, so it's not there's no on-prem solution. So it's all managed through a cloud console.
Yep.
And so all of your devices, so you would still have to go into Google's, the IoT core console to view all of your devices, manage all your devices. And this is, in that cloud console is where you add, remove, firmware update, if one happens to go missing or whatever,
yeah.
like that's where you'll cut your losses. So that way that device can no longer connect. And so how it would fit into your corporate structure there is, that's how you would have to use Cloud IoT Core, is through that. Because unfortunately, there are some APIs where you can loop it into dashboards and how you're collecting your information. So that's what I wound up doing with the alpha. There's a lot more endpoints available now with the Cloud IoT Core APIs. But so essentially what I did was just, once the device was added in Cloud IoT Core, I had a replicant made within Firebase. That way I could just track what was going on. But then if I needed to do any management of the device, push out a new firmware update or whatever, I was still using Cloud IoT Core for that.
Yeah. Okay, awesome. Yeah, and it seems like given that you can utilize the APIs to set things up and probably manage them, you might be actually able to build and utilize the APIs to sort of manage things at more scale.
Yes. Yeah, and I know one thing, personally I haven't tested this, but where you could do batch as well. So instead of trying to do a firmware update per device, so let's say you have 1 million devices out in the field, you don't want to sit there and hit each one with the firmware update. You could do a batch firmware update, for example.
Okay, yeah, that makes sense. Another question that we had, which is, and this one's kind of interesting. I mean, we don't always think about IoT devices as something that would be used for image processing, although, with the advent of cameras and smaller, lower cost sensors, do you know anything about or any thoughts on image processing at the edge, so that we're not trying to pass, a 1 megabyte image, over every single time an image is taken that might be taken, 20 times a minute, right? Any ideas about that, or thoughts about how someone might use that end of it?
Analyzing images at the edge. So with like Cloud IoT Edge and a lot of our edge processing that Google Cloud offers, we do have a lot of ML models that are designed for image processing. To that extent, though, I mean, they're only designed for let's say face detection or more simpler things. Like if your request is super granular, that's where you probably need to still capture that information. So let's say you have an IoT camera out there. Let's use a doorbell, for example. So the doorbell is going to be constantly, if it detects motion, that's when it's going to start recording any images or taking small pictures. And then if it detects a face, that's when you can use your ML on the edge it's detecting the face, and then whatever else that you're able to process on the edge. If this is an image that you need to send up via telemetry, your telemetry packet, I mean, that's where you're sending less, and so it's not as expensive to send that up to the cloud, if you will. Expensive, of course, meaning the size of the data packet that's going up to the cloud.
Yeah.
And the time it takes. So there are opportunities using the image processing to do that. So it just depends on how. It's hard to answer that question without knowing how granular you really want to do, like face detection or what you're trying to specifically see. And so the image models do have a lot of things that they cover, and how we've packaged them down. And I'm of course using the royal we because I haven't worked on the, the scale. Like we have a lot of super intelligent engineers that have worked to get these MO models, packaged down to where they could fit on these small devices. And so they're already pre-trained. All you have to do is reference them and via their SDKs, and you're able to utilize them for your needs.
That's awesome.
But of course, it's within whatever the model's been trained for.
Yeah, absolutely. And I know that there's TensorFlow Lite and stuff like that. I'm not sure if that is a related, related to this and can help that sort of situation out a little bit as well.
I don't believe you can use TensorFlow Lite on an IoT device, but potentially. I know TensorFlow Lite has really been more designed for web and mobile app initiatives. So that way, like if you're on an Android or iOS device, it's able to process, these ML models locally.
For sure,
yeah. And this is where you could use like Firebase ML or TensorFlow JS to do some of that stuff.
Yeah.
But yeah, I'd have to look in to see if how well if TensorFlow Lite also works with IoT.
Yeah,
I know we have the IoT Edge, so that's why I wasn't sure.
Yeah, if they're sort of similar, but yeah, no, it'd be interesting to know that.
Yeah.
Well, Kyle, thanks for joining us. I'm really excited to see as you build this out and as we get further down this path with IoT Core and yeah, no, I really appreciate you spending the time with us today.
Yeah, of course. Thanks for having me. And hopefully next time, because I meant to have a project to show off too, but I didn't have that quite ready either. So so hopefully next time, there'll be a new version of this talk with some fun stuff that I can show off with IoT.
Yeah, absolutely. And I know there's some other DevFest coming up that maybe that'll be something that works for those ones. So yeah, hopefully that all comes together.
We'll see. And yeah, stay tuned for my talk later this afternoon around becoming a Google developer expert. So I'd love to chat and hear all your questions then.
That's right. Yeah, we have Kyle Paul coming on at 12:40 Mountain Standard Time to talk about what it takes to be a Google developer expert. So thanks a lot, Kyle, and really appreciate you joining us.
Of course. Thanks for having me.
Okay, bye for now. All right,
Cheers.
Everybody. I just want to remind everyone that we do have the second stream. It is going on, and it looks like Neil would be wrapping up here pretty quickly. So if you have a couple minutes and want to go jump over into the expert stream and join Neil Karit, it is go.devfestab.com/livestream. Or sorry, /experts. So again, go.devfestab.com/experts. And we'll be back up and running here in about 10 minutes. We're just going to do a switchover. Our next speaker will be Martin Omander about growing your cloud application. Really excited to hear from Martin today. And that will be starting at about 10:25. So enjoy the music in between, or jump over to the experts lounge and ask some questions. You know what? I hear that Kyle might jump over into the experts lounge as well for a couple of minutes. So after, but yeah, anyways, opportunity maybe to ask questions of our experts. So thanks everybody. And we'll see you in about 20 minutes from now.
Small-time boy caught in the big city, losing all my joy for a life that don't fit me. I got the same old dreams as a million fools, stacks of green and swimming pools. And I used to swear upon wisdom, you got brains to spare, you gotta give some. I kick back a flare, my ignition, it's time to ride. When I need to feel alive, I just get in my car and drive. When life it starts to break my stride, been lifted with a fallen pride. And now I walk beside psychotic guides to listen to their whines and maniacal cries. Worship the dollar and cent, white collar descent. You holler and bent over the most tiny moderate dent. In your mountains of gold, accounts that you hold, you wound up an old young blood man. That fountain is cold. And I used to swear upon wisdom. You got brains to spare, you gotta give some. I kick back a flare, my ignition. It's time to ride. When I need to feel alive, I just get in my car and drive. When life it starts to break my stride, I just get in my car and ride. What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? And when I need to feel alive, I just get in my car and drive. When life it starts to break my stride, I just get in my car and ride. Ooh, yeah, 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 yeah. I'm gonna drive my blues away, yeah, yeah. Gonna drive my blues away. Just another sunny day.
Try to ride on the high of the days unknown. Memories filling me with the trace of all unknown. When everything's impaired and no one seems to care, I know I cannot rise above. 'Cause I'm alone just looking for love. Inside this dark I roam with all these shadows that I've known. I need a place to run, but I'm alone just looking for love. But I'm alone just looking for love, looking for love. But I'm alone just looking for love. I'm just looking for love. I'm alone just looking for love, looking
love you better, 'cause you're all I know, oh, you're all I need. But it's complicated, I'm my own safe haven, and it's not the way you believe. And I'm stuck in between what I know and what I feel. Why are we so unsteady, baby? Tell me. And you see right through me, but you still know what I need. Why are we so unsteady? Tell me. Like a single flame, baby, light the way. We don't need to think about who to blame. It's just so complicated. Promises keep breaking, and I hate that you are all I need. And I'm stuck in between what I know and what I feel. Why are we so unsteady, baby? Tell me. And you see right through me, but you still know what I need. Why are we so unsteady? Tell me. Why are we so unsteady? Tell me.
So I'll never say it would have ended like this. Oh, we went down on a limb, now we're standing in the middle of a mess. Go on and tell your friends, but me and my friends weren't good enough, weren't good enough. Go on and tell your friends, but me and my friends weren't good enough, weren't good enough, weren't good enough. Oh, 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 I never wanted this turn. Oh, 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 I never wanted this turn. Oh, 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 just every night. Here we go, on and on, will never end. Control is what you want. Gotta go, slowing down just won't make the cut. Doesn't work like that for us, so we go and we go and we go. Go on, tell everyone our dreams are too big and we are in over our heads. Oh, go on, tell all of me and my friends, oh, now this did all night, yeah. Been dreaming big since 99. Guess you're not coming for a ride. Been dreaming big since 99. Are you coming with me? Oh, 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 I never wanted this turn. Oh, 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 I never said it would be perfect. Oh, 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 just every night. Here we go, on and on, we'll never end. again.
Oh, I'm intoxicated. I got a legend on the way. I'm falling for you, baby. What can I do to make you stay? The bassline's taking over. We've come too far to turn around. So turn the music louder and let my feet not touch the ground. So many days and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, 'cause I'm still running out. So many days and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, 'cause I'm still running wild. Running wild. Oh yeah. Running wild. Oh yeah. Running wild. Oh yeah. Running wild. Oh yeah. Running wild. Running wild. Oh yeah. Running wild. Running wild. Oh yeah. You're making me colder. You make me wanna settle down, down. Get married and have a daughter, and live forever sweet and sound. But if I'm moving too fast for you, tell me honestly, what should I do? And if we're grooving too soon, let the playlist make the move. 'Cause I'm in a daze and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, 'cause I'm still running wild. 'Cause I'm in a daze and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, 'cause I'm still running wild. Running wild. Oh yeah. Wild. Oh yeah. Running wild. Running wild. Oh yeah. Running wild. Running wild. Oh yeah.
welcome back to DevFest Alberta, or DevFestAB. We are streaming live from Calgary. I'm in quarantine because of COVID, so I'm in my spare bedroom, but we are keying up our next speaker, who I'm super, super excited to talk about. Before we get into that, I just want to remind everybody that there is the Meet the Experts stream happening right now, which is at go.devfestab.com/experts. And you can join that stream as well. Also, please jump into the chat on YouTube and ask questions. We have an excellent session coming up for you right now. And so it is my pleasure to introduce Martin Omander from Google Developer Advocate at Google, talking about scaling up your cloud application. So welcome, Martin.
Thank you, Greg. Good to be here.
Yeah, great to have you. Yeah, I really appreciate you joining us. Quick question: where are you out of? Where are you from?
I'm from Sweden originally, so I understand Celsius, and but right now I'm in Mountain View, and Google headquarters is 2 miles in that direction. Although I'm not allowed to go there because the office is closed down.
Yes, of course. Yeah, no, I've heard that your cards do not even work anymore to get in, so you're not doing anything at the campus.
That's right.
That's awesome. You know, I met you a couple of years ago, and maybe we could talk a little bit about what you were doing at the time. Yeah.
Yeah.
Go ahead.
Yeah. My previous job at Google was I was supporting the Google developer groups in US and Canada, which was a lot of fun, and got to travel and be part of many excellent GDG events and seeing members and organizers. So much fun. Then 2.5 years ago, I switched over to I wanted to get back into technology. So I switched into Cloud Developer Advocate, where I work with customers and help them set up a Google Cloud Platform.
Yeah, absolutely. And, you know, at the time we were at the North America Google Developer Group Organizer Conference, and we had a really great time. And I do remember you walking everyone in the group all around Mountain View and showing us all the sites, which was super fun. And we got to see, you know, all kinds of places. And you've lived there in Mountain View for a long time, is that correct?
Yeah, gosh. 20 years now. Oh my gosh, time flies. Yeah.
practically an OG Mountain Viewer, eh?
Practically, yeah.
Yeah, that's awesome. And you've been with Google for a long time as well, is that correct?
14 years. Yeah, Google is a hard place to leave.
Yeah, no, I can imagine that. Yeah, Mountain View is beautiful. So yeah. So anyways, yeah, just thank you so much for joining us. And I think we're ready to let you take it away. Is there anything that you have questions about before we get going?
No. Yeah, just for viewers out there, as Greg was saying, feel free to ask your questions in, what was it, in the YouTube stream, Greg?
Yeah, in the YouTube stream. So the stream is at go.devfestab.com/livestream.
Excellent.
So, yeah, absolutely.
Yeah. And I will pause for questions here and there throughout the talk, and there will be some Q&A time at the end as well. So think about questions. I think that's one most fun part of a talk like this.
Awesome. Yeah, and I'll be here for the rest of this, and I'll just be quiet while you work through it.
All right. Thank you, Greg.
All right. Thanks, Martin.
So today I will talk about scaling up your cloud application. But just a brief intro. Well, you heard some of what about me, but this is what I look like when I wear a denim jacket. My name is Martin Omander. As you heard, I'm born and raised in Sweden. Oh yeah, you heard about this too. I lived in Silicon Valley for 20 years. I worked at 3 startups as a software engineer before joining Google. That was 14 years ago. I joined Google. Worked at a bunch of different roles at Google, supporting GDGs for 5 years. That was so much fun. And now I'm a cloud developer advocate. So that means that I help customers, help developers build awesome stuff on top of the Google Cloud platform. And I've been doing cloud and serverless since 2007 because that was when App Engine came out, before people even talked about platform as a service or anything like that. So this talk will be about how, as developers, we are still kind of figuring out this cloud computing thing. So there are some things in computer science that we have, figured out, like compiler design, for example, is pretty well known by now. But cloud computing is one of those things that's newer, right? So as developers, we're still grappling with this, and we're still sort of mixing our various products and see if it blows up in our faces or if it turns out great. And this talk will be about some of the things I've learned as I've worked with customers who build cloud applications, and as I built cloud applications myself, and I have a hobby application that's getting hundreds of thousands of users every day. So truth in advertising here, this talk will be about how to cope with application complexity as your application grows, sort of growing pains, if you will. It's not about writing hello world. This is, I'm thinking, when I'm thinking cloud application, I think of an application that is a backend for a web application or a backend for a mobile app. And yeah, it'll be these hard-earned lessons that, I've made many mistakes when building my own applications or when seeing customers build their stuff on top of Google Cloud Platform. So what this will not be is, this is not about tuning app performance, plenty of materials on that. This is more of architecture, design, and organizational ways of dealing with additional complexity. It's not about how to write web apps or mobile apps. There are other great tracks, other great talks for that. And yeah, there won't be even a single line of code, which is unusual for a talk by me, but I think there are plenty of talks that deal with code. So first off, in the 50s and 60s, there lived a man who was far smarter than me, a Canadian, as a matter of fact, Marshall McLuhan. He was called the prophet of the information age. He basically predicted the internet in the 50s and 60s and predicted many of these trends and we're seeing in society because of internet. He figured all that out in the 60s. But he said one really smart thing. The social and educational patterns latent in automation are those of self-employment and artistic autonomy. Sounds great. So this is, he came from academia, of course, so this is a very academic way of saying automation leads to artistic autonomy. And that is very important when you're building cloud applications, because we want, as developers, we want to have that artistic autonomy. So there are two ways that I've noticed that you can give yourself that artistic autonomy through automation. That is by automating monitoring, but you have to do it in the right way. If you do it in the wrong way, it won't work. And you have to automate testing. But again, if you do it the wrong way, you'll just spin your wheels and it won't lead to this artistic autonomy. So let's talk about how to automate monitoring in the right way. So I built a beautiful dashboard for an application, one of my applications, and I can see all the different stats and the technical and business metrics of my application, but that didn't help when the app started failing. There was like something started going slowly in one end of the application. It had ripple effects throughout the application. It increased my costs by 10x for a day. My dashboard didn't help me there. So monitoring is nice, but you aren't really monitoring unless you have automated alerts. So dashboards, they're great for helping you troubleshoot things, but and reports are great. You think when you set them up, you think you'll be in there looking at them every day, but you won't. After a few weeks, you will forget to go into those reports. So automated monitoring that proactively reaches out to you and tells you when there is a problem. I did not have that. I had put lots of time into dashboards. That didn't help me one bit. So there are a few easy things you can do here. One is you can install on your phone, you can install the Google Cloud mobile app. If you're running stuff in Google's cloud, then this application will actually tell you, hey, there's a new error in your cloud project that we haven't seen before. And it happened this many times. And the first time was this, and the most recent time was this. Excellent way. So, and that requires nothing else than just clicking and tapping an app. Then if you want to go deeper, you can read up on Google Cloud Monitoring and custom alerts. And there you can set up really detailed and certainly worth doing. But if you just want to do one thing, install the app, Google Cloud app on your mobile. The other part was testing. So again, artistic autonomy, you can get that through testing, but only if you do testing the right way, in my experience. So my app didn't have end-to-end tests, and I've shipped breaking changes many times. And none of those breaking changes were prevented by the unit tests I had. So basically, those unit tests maybe made me write code a little faster, maybe not. I don't know. The jury's still out on that. But those unit tests don't tell you anything about whether you're breaking your application. So testing, and then of course you start reading up on testing, right? We all done this. You read about unit tests and integration tests and end-to-end tests and testing frameworks and automation of tests and Selenium versus whatever the other one is called. And there's so much. It's a rabbit hole of infinite depth, and you can spend all of your time just studying, reading about testing or implementing tests that aren't that useful. So here is the way I think it should be done. You add tests to risky code or new code as you're writing it. And then you add end-to-end tests for critical user journeys through your application. Now, this is super important. And then you add tests when bugs are reported. Now, here's actually one interesting thing. There aren't, from what I've seen, there aren't that many robust end-to-end no-code web testing tools. There are a few, some of them are expensive. I'm still looking for a good one. I want a no-code tool because the tools that are out there now are so very brittle. You change the name of a text box or something, and you have to rewrite all your tests. So, but if you're serious about running a cloud application that has real usage, you need to somehow set up end-to-end tests. Unit tests are nice. End-to-end tests are a must for artistic autonomy. All right, so that was that for automation, artistic autonomy. Next, we have another person who's far smarter than me. This guy from the Czech Republic, Franz Kafka. He said, productivity is able to do things that you were never able to do before. So you may, you may have a code editor that, tells you about missing semicolons and things like that. That's, I guess, nice productivity. It's not really productivity changes. We are looking here for the 10x things, the things that will make your help you jump 10x in productivity so that you can do completely new things that you weren't able to do before. And I think my hard-earned lessons here are there are two ways to really get productivity. First is you need to stop and think if you're productive or if you're just busy. I've seen many, many developers, including myself, who just we're busy all the time, but we're not doing the right things. The second one is to understand and love IAM. So this is privileges and access roles in your cloud. Let's dig into the first one. So are you productive or just busy? It's very easy if you're in the heat of things and in the middle of things and reading up on stuff and implementing new technologies and writing code. It's very easy to become busy, but not productive. So here's something I did recently. I read up on VPC, virtual private clouds. Sounds amazing. That's perfect for my application. I started, I should implement that. I almost started building stuff using it. But then I realized, hey, what I have now is actually kind of good enough. End users won't notice a difference. I would sure be very busy with this virtual private cloud technology, probably for months. I would feel productive. Would I actually be productive? No, it turns out. I talked to users, I did some introspection, I stopped to think. This virtual private cloud technology would do nothing for users. It would help me. It would make me busy for a few months. But if it doesn't help users, I'm just busy, not productive. And that is because we as engineers, we're used to solving problems that we know how to solve. So just like setting up a virtual private cloud, some of us are great at setting up virtual machines. Some of us are great at configuring networks. Some of us are great at setting up security settings. But then you have to stop and think, is that really your comparative advantage? Is the secret sauce of your organization that you are that best at setting up virtual machines? Maybe not. Probably not, I would say. You have to think about what is your secret sauce. Probably that is you understand your users better than anybody else. So all that setting up virtual clouds and configuring networks and setting up virtual machines, let somebody else do that so you can do the productive stuff instead of just being busy. And the way I think about being productive here, now remember, we're not talking about being twice as effective, productive, or 3 times as productive. We're talking about 10 times productivity. For that, I think that for any greenfield application you're building today, serverless is the way to go. So here are 3 serverless products in Google's cloud. And of course, there are in the other clouds, there are similar products. Go serverless whenever you can. Start with serverless. Try to build your thing in serverless. If it doesn't work, you always have the option to drop down to a lower level. But don't start designing something with virtual machines just because you've been doing it in the past and you know how to do it. Be productive, not busy. Next, we have IAM. How are you supposed to pronounce this? If you know how to pronounce this in a good way, please tell me. This has to do with roles and privileges and access. Boring stuff, I thought. And it was very boring until from a production database. I thought it was the test database. So yeah, of course, I'll delete these accounts just so I can have a clean test database. Well, then it turns out I was deleting accounts from the production database. So this made a light bulb go off in my head. IAM, roles, privileges, they aren't there to protect from hackers, like I thought, because mistakes, like myself deleting thousands of accounts, mistakes are far more common than hackers. And Hanlon's eraser comes in here, right? Never attribute to malice that which is adequately explained by stupidity. So thousands of records gone from the database. Oh my gosh, what is going on? Has a hacker been in here, was my first thought. Well, Hanlon's eraser would say that maybe this was due to somebody's stupidity, and sure enough, it was due to my stupidity. IAM is there to protect you from yourself. And incidentally, it also protects you from hackers, but who cares? There aren't that many of those. So the way to do this right is to study IAM. I had not done this. Study it, get to know it well. Dare I say, get to love it. Really know the ins and outs of it. And then you set up your environments, right? You have one production environment. Developers have very little access to that, if any. You have a test environment, one or a few test environments. Developers have a little more access. Maybe they can see the data in it because it's test data, but they can't change config settings. And then you have one development environment that is cloud. We're talking about, when I say environment, I mean cloud projects. So we have one cloud project per developer, and they can change anything in their cloud projects. So but you enforce that with IAM. So no developer accidentally goes in and deletes a bunch of production data like I did, or a developer goes in and accidentally sees a lot of production data. There might be personal data in there that only certain people in your organization should be allowed to see. All right. I am good stuff. Next, let's talk about Diogenes. So he was a founder of the Cynic philosophy. He had some great, he lived in a barrel. You often see him depicted in a barrel or next to a barrel. He said very wise things. We have 2 ears and 1 tongue, so that we would listen more and talk less. And here, listen, my main lesson learned here is listen to your users. And we can all say that we should listen to our users. So how do we actually do it? Well, we do it through these 3 things here. Let's go through them all. If we just say that we listen and we all can agree, then it's just a platitude. We must actually do very specific things to actually listen. So first of all, 0 effort feedback. This takes some work. It's 0 effort for users, not for you. Not for you, not for me, not for us as developers. So in my application, again, I always, when I build something new, I always add a feedback form. In one of my applications in the past, a user reported that one feature of the app was broken. Well, it wasn't broken for me because I had a test account and I had a whitelisted account, so that feature worked for me. I would never have known that that was broken for users because it wasn't for me. You must have a way to make it super simple to tell you about things going wrong. They shouldn't have to hunt around in your mobile app or on your website. There should be an easy way for them to tell you. So let users send their feedback with minimum friction, even if you don't do anything about what they report to you. Even if, well, you should respond and say thank you. Even if that's all you do, your users are happier. For bonus points, you actually do something about the feedback you get, and users will be even happier, and your application will become much better. So always set up a feedback form in Google Forms, for example. You can set it up in your, this is super easy to do, in your mobile app or your web app. You can even capture the browser's user agent string in this form. So you can see, like, if it's a web application, this user used, Firefox version so-and-so. And then what I usually do, I set up a little Google app script that just translates those user strings to sort of readable thing. And so instead of it saying Mozilla 5.0, blah, 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 it translates it. So it's like Firefox version 67. Set this up, not 0 effort for you or me as developers, but 0 effort for users. And whatever feedback process you set up, think about how you can make it easier. Shadow your users. I was going to say stalk your users, but that sounds ominous. They are in your application. You can actually, if you put some effort into it, you can see what they're doing. Whenever I put a new button into a mobile app or web app, I always put Google Analytics tracking code on it. So I see what aspects of my app people are using. So for example, very few people use Twitter integration in one of the applications I built. That's useful. Facebook login, I had that in an application. It was very popular. It broke. No user told me about it. They just assumed I had done something wrong. I don't know. But through my tracking, where I saw how many people clicked the Facebook login button, how many people succeeded logging in, I saw that drop off there. It was, 20% at first, and then it went to 100% drop off. And that was because Facebook had enacted, they thought I was breaking some policy or something. But I think I was breaking their branding guidelines. But if I hadn't put tracking on this, I would never have known. So, and this data should, of course, inform your dev priorities, because it's very easy to be busy and not productive here. I might work on this Twitter integration that none of my users are using. So create funnels, also track client errors. You can do that in Google Analytics. You set up, one error, then send an event to Google Analytics with the tracking code. So set up Google Analytics or Firebase Crashlytics if you have a mobile app. It's a bit of work, but you'll be happy you did. Once you've done that, you have the option of going further. You can set up more advanced tracking tools that you pay for, like LogRocket, for example. For web apps, LogRocket captures basically records a video of what your users are doing on your screen. So you can see not only crashes and things like that, but also how are people using it. And you can see mouse movements and such. So you sort of see when people are confused because the mouse moves around. Okay, that was shadow your users. Okay, listen to your users. So your users actually, they're okay with your knowing what they do in your application. They realize that you can see what buttons they're clicking on and so on. What they don't want is you to see their personal data. So you should listen to them. And personal data, actually, you may not need it. Personal data is a huge liability for us as developers and maintainers and operators of cloud applications. So again, this is an application I had things sorted, accounts or stored under users' email address. That was the key in the database, email address. That was a scary thing to have in my database. That is personally identifiable information. And it turns out I didn't actually need email address. I had just made the decision, let's make the key email address because that's easy and it's unique. But I could have stored this under another key. It's scary to have personal identifiable data. You might need, you know, if you have users in Europe, you might need you need to figure out how GDPR works. You may need to have a data protection officer. You may need to set up all these processes to deal with personal identifiable data, notify people when there have been breaches and so on. If you don't have PII in the database, personal identifiable information, there's so many things you don't have to do. And it turns out that in the past, we really needed personal identifiable information. But many of the modern single sign-on solutions, we don't need it anymore. For example, Firebase login is part of Google Cloud that if you want, it can give you the user's email address. You can also opt to just get a numeric key. So you know that Martin is always 123, Greg is always user number 456. Well, actually, you don't know that Martin is 123 and Greg is 456, but you see only that, oh, user 123 came back or user 456 came back. And you can key off of that. Now, as you can keep track of a user, bring up, you know, what the user did before or their saved work or whatever without knowing who the user is. And all of a sudden, you don't have to worry as much about GDPR and data protection officers and stuff. And users will be much happier too. All right, so mistakes happen in computing. What happened here? Aha, mistakes happen. Excellent timing. Mistakes happen. Your screen can go black. For example, a computer lets you make more mistakes faster than any invention in human history. Computers are amazingly efficient at this. The only exception to this might be handguns and tequila. And I overheard this at a party from somebody drinking tequila, and I hope that person didn't have a handgun. So there will be mistakes. There will be lots of mistakes because computers are so good at making them fast. So you should plan for failure. That means backups, code reliability, and deployments. Let's talk about each of these three. So first off, with backups, there is no try, only do, as Yoda would say. It's very easy to set up backups in a way so that you've sort of made a good faith effort to set up backups. I've done this. I set up backups, fairly easy to do. I didn't test restoring a backup. Then when there was an urgent situation and the application is on fire and users are writing in and where's my data and so on, now you're in a stressful situation and now is the best time to figure out how to restore these backups? No, it isn't. Also, these backups, you might fail to restore them because you haven't practiced this, or they might restore in a way that you don't expect. That happened to me. So one, you should take backups. Okay, I hope that you're doing it, backup in your entire database, for example. Now you think you have backups, but you don't. You need to automate your backups. you can't really say you have backups if they're done manually. Automate them. For example, midnight every night or every 2 hours, or yeah, whatever works for your application. But you don't really have backups yet. You might think you do, but you don't really have backups until you tested restoring them. They could break, they could work in unexpected ways. Put that in so that every month or so, you just try out restoring. That should be part of sort of monthly maintenance work, practicing this to make sure that everything works well. Now you have backups. If you only take backups and take them manually, you don't have backups. So the good news here is that Firestore, Cloud SQL, all those database products within Google Cloud, they all let you back up to cloud storage. Cloud storage is sort of the file-based product. It is your own file area for files within Google Cloud. So these products, it's pretty easy to take that backup. It's pretty easy to even automate backups, so you can set up schedules. Now, and then manually you would restore backups and recover. So that is the thing you will need to add and make sure you do every month. Get to know the system. Code is a liability. Yes. So this might be hard for us to think about sometimes as developers, because code is also our work product. This is how we show that we do something. But it is a massive liability. If you can get away with half the amount of code, you have half the liability. If you can get away with no code, you should do that and you have no liability. So I needed alerts from my system to show me when things were really failing spectacularly on the website. If I had less than a certain number of users on the website. I started figuring out how to write code for that. It turns out you can connect Google Analytics with another product called Stats Glitch. You connect that with another product called Easier, and boom, you have all that set up. Like if ever is 100 users on the website, send a text message to this person and tell them there's a problem. In a zero code way. I mean, I could have written code for this and actually started. That would have been 100 lines of code. 100 lines of code means that on average there would have been 3 bugs. I didn't want to have to find those bugs, maintain, fixed, and so on. Also, even if I write the code, that is just the start of the journey. That code has to be forever maintained, and I have to do troubleshooting, and it's one more place where things can break. It's a massive cost, not just to write code, but to have code in your system. So less is more here. And it turns out that right now there are tons of startups that have very good services and low prices, and these startups are funded by venture capitalists. So they have really good pricing, like Stats Glitch, Phasier. I forget how much they were. It's like single-digit dollar amounts per month to use these services, and you have just got rid of thousands of dollars of liability in code. Use those third-party tools out there. Or use open source software in your own cloud project, and you can have less code, less liability. Finally, deployments. They should be small and frequent. So config values, it's good to have them in the database. I'm very happy that I started doing this. All the tests in the world can't find all your bugs. So and rolling back is hard when there's a new bug. So instead, you have little feature toggles on, so you can start releasing a feature bit by bit without exposing it to users, and then turn on that toggle, and boom, that new feature is activated. If it breaks, you turn off that toggle, boom. The code is still there. You don't have to do a new deployment, but the feature is deactivated. Google does this all the time. And then, of course, canary deployments. If you can, if your platform supports it, when you have a new version, let 1% of your users see it. If that works out well, 5%, 10%, 20%. If it still works great, flip over 100% to the new version. So in Google Cloud, Cloud Run lets you do this. You have your various containers. It's based on Docker containers. So you can say, like, send 1% of traffic to this new container and 99% to this old container, and you can see if it breaks or not. And also, if you're using Firebase, you can do remote config of mobile apps. So you can even say things like, the background of my app should be blue, and then, no, I think it should be red, and you change something in the admin console, and boom, it changes for all the applications out in the field without your users having to update, reinstall their mobile app. Cool. So in conclusion, let's experiment. Go out there, be awesome mad scientists, mix and match, do crazy things, and write down what works, what doesn't. Many things will blow up in your faces. Many things will work amazing. Cloud applications, cloud computing is still a relatively new area, so there's lots to discover here. Just remember, build stuff that your users love, and go forth and have fun. And that's it for me.
Awesome. Hey, Martin, thanks for sharing that with us. I know that we were looking for some questions to be coming through on the live chat. We might be having issues, but I don't see a lot of them right there. Let me just check briefly. Otherwise, I have a couple of questions for you myself. So, yeah, so interesting that you mention, learning IAM. Is that something that you think that maybe you neglected or just didn't pay enough attention to? Or, in hindsight, when do you think that is something that you would have maybe picked up and run with? Would have helped you along the way, I guess, in your journey as a developer?
Yeah, for sure. It's so boring, and it is so boring, and sometimes a little hard to understand, let's be honest. And because you have roles, and you have privileges, and you have rules, and you have so what I should have done is, there are courses out there, for example, on Coursera. They have excellent courses that you can take that is like Learn IAM on the different cloud platforms. So I finally took the one about on Google Cloud, IAM on Google Cloud. And of course, I should have done that years ago. For Pete's sake, I'm a developer advocate, but IAM just seems so boring until you end up deleting thousands of people's data.
Yeah. Yeah, no, it's not hard, right? And like you say, it's not almost like, the attackers, or, it's not always malicious attackers. It's people that are fat fingering something or just not paying attention and deleting stuff. Actually, I did that exact thing. I deleted my whole G Suite account there the other day. I thought I was creating a different one, and again, it's not much, right, to take down a production system, and that's sort of my everything, my work and everything. So I just did that about a couple weeks ago. So,
oh my gosh, yeah, right. And if I can't keep track of, I'm a one developer show for this application. One would think that with one person, you should be able to keep things separate and understand. If I can't keep track of it, and I think I'm a pretty smart guy, if I can't keep track of it all by myself, I'm only have one person to communicate with, myself. How do you think you're going to keep track of it with a team of lots of people, perhaps distributed team where not everybody knows everything all the time and not everybody talks to everybody all the time? You can't. You need to just set up IAM. Spend lots of time on this.
And I've heard also related to that point, Google themselves have said in the Building Secure and Reliable Systems handbook, which is an SRE handbook, that I think it was like 60 or 65% of all outages at Google are not related to attackers or anything like that. They're related to rolling changes that had an unintended consequence. And not necessarily the changes weren't intended to be rolled, just that they were rolled and they had cascading effects, which sort of takes you to your point around code as a liability.
Yes.
We don't always intend to have something break when we roll it, even if we've tested it, right? Maybe we just forgot something, or it cascades down, and it's 3 or 4 layers later that it manifests as an issue. Any experience with that, or anything that you would like? Anything else? Any experiences you might want to share about that at all? Or
Yeah, I mean, I think that, again, most of the software I write is internal tools for our team or cloud applications I write myself for the public, but I'm typically a developer, a team of one. So this should be easy to keep track of. But it is hard, and because of these layers upon layers. So for example, my outage, one outage I had that I briefly described here, but the outage was basically that it said that your cloud functions are taking too long and you're running out of cloud functions quota because you're using up too many CPU seconds. So, okay, I guess I'll go in and increase the number of CPU seconds in the quota. And I requested a quota increase, I got it. And then it just filled up the new quota. And like, maybe something is wrong here. And then it turns out that it was because a database query was taking too long. So all these functions were hanging there waiting for that. So then of course you have to look at, why did I change the query? No, I didn't. And that was because something else again was wrong in another layer where I saved things in the wrong way. So that was just, that cascade was 3 levels deep. And that wasn't a one-person project.
Yeah.
Yeah, and that will be far worse if you're 2 or 3 or 20 or 30 people. You will have far longer cascades.
Yeah, absolutely. Well, thank you, Martin. I had one additional question, but we're gonna, if it's okay, we're gonna cut now, and I'll post it to you, and then I'll post the answer back in the chat. We had one additional question. It was related to it was related to something that you talked about called Load Rocket, and basically folks were just looking for a URL. So maybe if you have that handy, we can go offline with that, and I'll grab you on that. But thank you so much for taking the time today and joining us for this. It was really insightful, and you know, these stories from the trenches are probably the most valuable ones, because hopefully we don't have to spend the time and the effort and the pain learning them ourselves. So thank you so much for sharing your insight and your years of knowledge. And yeah,
thanks for having me, Greg.
Much. So we're going to move now, and just as a heads up, we are experiencing latency on the feed. So what we're going to do is try to reset a couple of things and come back. Just so everyone knows, there may be a chance that the feed will be interrupted. If need be, you'll still be able to use the same link to access the feed. So even if we needed to move to a new feed on YouTube or whatever else, we will make sure that it's the same feed. So it's go.devfestab.com/livestream. So just hit that every couple of minutes over the next bit. So we have a 20-minute break here before the next speaker, and we'll be working to sort these issues out in between. And other than that, thank you so much for joining us today. So again, we'll see you back at go.devfestab.com/livestream. And I'll also post that into the YouTube chat for everyone's knowledge. Again, if anything is interrupted, we'll keep the link persistent, even if the actual stream changes. So thank you so much. And thank you so much for joining us today, Martin. We'll see you all in about 20 minutes for Martin Kodok to join us. Thanks a lot.
to hold on to, gotta find it first. But here
next to me, you're incomplete. I need you here tonight to cover up these empty sheets, 'cause I'm incomplete. Yeah, I'm incomplete. Hey, 'cause I'm incomplete. I need you here tonight to cover up these empty sheets, 'cause I'm incomplete. At the crack of dawn, I imagine you waiting by my doorstep. But it won't be long before I realize it's a picture in my head, in my head.
Girl, you be my love, you be my other half. That's real. Know that I be missing you when we're apart. Yeah. Felt for you the second I laid eyes on you. I believe it was fate. Meeting you was written in the stars. Yeah. Real. Girl, you be my one, you be my own. Trust. Promise that I'll never leave you lonely. Never. Said you be my lover and my home man. So I'ma keep it real with you always. Said I'ma be there whenever you need me. Anything you want, I'll get it. Call me GD. Knew you were the one when you said you would ride for our brother, no matter the weather, and you never leave me. Baby, let us fly away without no delay. So where the sun be shining, we can take it easy. Just me and you in some incredible scenery. Yeah. In the night, speaking love, I know you feel me. In the night, we making love, I know you feel me. Before I be without you, baby, it kills me. Yo, I be looking for, I'm giving you the room, babe. Just say the word, and baby, by your side, I want it. I was feeling empty, but now you feel me.
But traveling costs and accommodation.
I'm a curious man with some curious genes. I get that from my dad. I'm not far from the tree. I flow like I'm a butterfly, sting like a beamer. I hate features. Got my running around with my head in the clouds. Been lost and then found. When they woke up and frowned, tell myself I'm the man. I was right to be left. Now I'm back to myself. To keep on holding you from everything you want. I can see you want to what you want. Who am I to? Who am I? Da, 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 da. Who am I? Da, 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 da. Who am I to?
welcome back to DevFestAB. This is Greg Bennett from GDG YYC, or GDG Cloud Calgary. Thank you so much for sticking with us. We just had to work through some latency issues, as you might have noticed, and we hope that that's cleared everything up. The feed should be stable. Feel free to comment down below if you have any questions, if you're still experiencing a little bit of latency, and we're going to try and sync things up pretty well. But yeah, we're excited to have you back. We have 2 streams going on right now. I am going to be working with Martin Kodok, but I also want to let you know about the fact that in stream 2, which is the Experts Lounge, we have a speaker on right now until 11:50. So Rakia bin Safi on realistic faces generator using AI, and you can join that stream. Of course, you can watch both streams at the same time. But feel free to jump into the Experts Lounge as well, which is at go.devfestab.com/experts. So again, that's go.devfestab.com/experts. And other than that, we will keep going. So we're a little bit behind here. We will work through the whole period and with Martin here. So I just wanted to welcome Martin Kodok here to DevFestAB. Welcome, Martin.
Hello, Greg. Welcome to be here.
Super happy to have you. And as I understand, you're joining us all the way from?
Oh, yes. I'm joining from middle of the Europe, from a country named Romania.
That's awesome. Yeah, and we're really happy to have you here. We've got a couple of speakers from all over the world. So I recognize that it's probably it'd be super late, either in the morning or super late at night. I guess it'd be almost midnight.
Well, yeah, it's past 8 p.m. It's dark since 5 p.m. and it's not super late, but anyway, coders and developers stay up all the night, so it's not a problem even if it was too late.
Yeah, perfect. Well, we're super happy to have you, and we're really looking forward to your talk today. So in terms of that, so I'll let you jump into it, but we're going to hear from Martin now on serverless orchestration and automation with GCP workflows. I did want to ask one additional question, which, we do have a lot of experts joining us today. And Martin, as I understand, is very well respected on Stack Overflow. Martin, how many points do you have on Stack Overflow?
Oh, yeah, it's constantly changing, but right now I have 100,000, 85,000. Oh, that's huge. 185K.
Yeah, I don't think I've done anything 185,000 times, let alone reply to comments and help the community out. So we appreciate you taking your time here, and we'll let you get running. And so that's incredible. So thank you so much for joining us. And feel free to take it away from here.
Good. Okay, so today we are going to talk about a product, Cloud Workflows, which was launched on Google Cloud Platform this year. And let's see the presentation, how new things that I will talk about this today. So about me a bit, I'm a very, very top user on Stack Overflow, the top 3 Romanian right now. I'm also a Google developer expert on cloud technologies since 2016, chosen and nominated based on my people reached numbers, which is over 10 million. I am actually working as a developer in Romania at a local company, and I daily work right now with Redis and BigQuery databases, but I have done so many things, architecture and all kind of serverless and scalability stuff in my projects. This presentation and other feedbacks will be on SlideShare and Twitter, and on GitHub you can find me under Pentium 10. That's my strange stage name. So our agenda for today is discussing challenges in connecting services, and I talk about here developerish, and what we will see that workflows is HTTP-based service orchestration and how we can use to automate complex processes inside the cloud or outside the cloud as well. And we will see practical use cases and jump to conclusions as well. As the time is very limited, I will keep it only to the essentials. Hopefully, we will get to the end of that. So as a developer, when I'm trying to connect things, and always there is two parties in connecting services, one of the most thing that should be actually easy and everything needs to be at the top of the shelf here is the connectivity. And in reality, you need to figure it out because it always has different connection format, and it would be good to have actually a common connection format. So what I put here as an ideas is that we are going to see how cloud workflows actually addresses these kind of problems. So when we talk about connectivity, actually making the connections, fallback, retries, parsing the results, and actually doing decision conditional step executions could be one of the hardest part to implement in a reliable way. And also logging and error handling, which I name them developer universal right, it should be there when we are developing certain service. If you have to do all these for every service that you currently work, it would take some days or even weeks in order to implement a new service or an authentication. And I want to also mention that you may have a requirement to scale down to 0, and that's almost impossible right now, only if you go to serverless products. But let's see how this works in workflows. So we are introducing Workflows, a Google Cloud Platform product launched this year. And let's see what this brings to the table. As you see, if we are going to put it together on the portfolio, there are the serverless products, which are Cloud Run, Cloud Functions, App Engine. Also, there are a bunch of APIs. Usually, Google adds every 2 weeks a new API. It's always more than 80 APIs there are. And also external APIs like mailing services, invoicing services, and the workflows are integrating with all of these on top of together, like with everything that works on HTTP. So, in essentially, what is GCP Workflows? I would say that it's a step engine. It's a managed service on cloud. It's extremely simple to work with. It has a YAML declarative workflow language, very decent pricing with internal steps and external steps, and you can count internal with inside the cloud and external when it reaches outside the cloud. For developers, it has very, very good features like built-in decision, conditional execution, sub-workflows, supports external API calls out of the box and outside of the Google Cloud. And of course, when we are talking about authentication, the best benefit is that it integrates with any Google Cloud product. And this is very helpful because you don't need to work with the authentication differences that each service may have for this. So if we are going to see that one of the main features is, as I mentioned, authentication. And here you see that eventually Google Cloud, and generally speaking, anything which is HTTP and API based is already reliable, and it's already a possibility in Google Cloud Functions. You can call it even private APIs. I will show it later as a demo for you. Or you can just by 6 lines call all Google Cloud Platform API endpoints. When we talk about security, it's enterprise ready because it already has all the integrations for the authenticated invocations. You are actually having a way to authenticate to all the services based on service accounts, based on IML rows, and each kind of attribute to that. It's audited, and nonetheless, it has integration with Secret Manager. And Secret Manager is another new product from Google Cloud Platform. And it's very good that because you are able to set a secret into the Secret Manager, and it's only visible there at the definition time. And in the applications, they are loaded at runtime. Also, it has encryption at rest and in transit, so it's great to have all your audits and all the policies that you need to meet on the enterprise level. A minimal code example, as I mentioned, it's based on YAML syntax. So you have a step, which is the top level. You have an action, which is in this situation is a HTTP GET, or here a switch. And then you have a specific way to define that kind of action. And there is the result, which is going to happen when the step is going to be executed. Visually, as you see, you have an input. There is a cloud function that's being called, and based on the decision, the workflow either stops or it notifies another service by calling it based on HTTP post in this example. So literally there are 15 lines and you get a step engine out there. So let me show you how it works with the Hello World example. And here we have Hello Cloud workflows. You need to do 4 steps. The first step is to define a YAML file, which just 2 lines to actually run the Hello Cloud workflows. You need to deploy it. This is the name of the service, which is called Hello, and the source file for our engine or our function, whatever we call it. Then you need to execute it, and you have a data param, which you can add inputs. And later you can describe the execution, because execution is asynchronous. So whenever you execute it, you get the response quickly, and then you need to describe all your executions. In the executions, there are different variables. The result is one of the most important. Here you have the result, which is either string or JSON based. For you, you have also the revision ID, because you may have run different versions of it, and you can have the start time and the end time and succeeded status for that. So this is the basic example by using gcloud, and you can do this also on the API side, and also from services like Cloud Scheduler. So it's not just from the command line you can run this. Let me show you a couple of sample workflows, what you can put together. So, for example, if you have to generate an invoice for an e-commerce solution, you have here a step orchestration possibility, which advancing only if there is no error. If there is an error, there is an inbuilt retry handling. And you have all this orchestration ability to actually connect different services. And I want to mention here that you can build polyglot services, which mean that you can have the create invoice in one kind of application, one kind of language. You can generate PDF with a different language system, and you can send PDF either with a service provider or an inbuilt solution for your use case. If I want to process with providing you another example, you have here another example where there is a function to get a list of customers. Normally that process is an array. And then you have the ability to loop the array, and based on a parameter, you are able to send eventually a reminder or execute whatever you want conditionally. So it's awesome for developers to actually orchestrate all kind of small things inside the cloud. One is IT management automation, which could be combined with a scheduler, which eventually trigger at 9 a.m. to start a service. It could be a compute engine VM or a Tableau server, Tableau desktop server. And it has capabilities, the step engine has capabilities to actually sleep or wait in order to the process to boot up and to be ready. Then you can eventually test it if it works or not. You can further log the event and eventually notify the team, for example, on a Slack channel or all kind of chat application services. There are endless possibilities here to build out. Google Cloud Platform has 400 products, more than 400 products, and you can build out all kind of interactions between all these services without setting up a function, without setting up a virtual machine, and all these to be serverless. Let's dive into a more technical way, showing you how to define simple use cases. One is making a post request, and I've chosen this for Bitly service. So today, if you want to implement the Bitly link shortener, you need to grab a library or you need to implement a strange call. But here in 13 lines, you have all this implemented. Your token is visible here and it needs to be placed there. The rest of it is taken care by the workflow. How it works is that it does a HTTP post request with the URL. It has the headers as a definition. In the body, this is JSON. Usually people are asking how body is constructed. So this is by default a JSON. You set the domain of the shortener, what long URL do you have there. You can have this as an input parameter for the service. You have the result and you return the body or a particular things for it. Another thing is if you want to connect two steps, and sequencing is the process that I want to describe here. You have actually 3 steps here. You have a get current time, which returns the current day and current time in a variable. Then from the current time, we are using day of the week to actually have the search on Wikipedia, a minimum example for this. And then in the third step, we are returning this wiki result and the body of first element of the body for this. This can also be much more versatile, and developers need to have conditions. On the screen, we have the switch condition, and here you have actions, like in the next key, you can name that the Friday action is going to happen next. And this is how the conditions are actually making the routes inside the step engine. And you have it defined Friday, weekend, work week as an action with those names. One of my favorite things on the cloud workflows is that I'm able to do sub workflows, which are very, very good because I can reuse the code. And by reusing the code is that the YAML file can be generated from your favorite syntaxes and languages. And by having the ability to call a sub workflow like name message with arguments, you are able to actually include, when you generate the body of the workflow engine, the function, as an additional function, as an include. And this way your code it's much more simpler. to actually build out code and manage a full application. As I mentioned, it has inbuilt retries, and here you have a predicate which is documented and you can change it. You have max retries, backoff, and all kind of things that developers love to do this. So I will say about the conclusions. What I love is that it's very reliable, it's enterprise ready, it's serverless product, but it has, let's say, no cold start, because every time when you call execute, it's there and it executes immediately. It has built-in error handling out of the box, so that's very convenient when you develop and you don't need to build your entire wrapper for the service. You can have inbuilt variable parsing and changing base 64 and JSON, these kind of things that usually people do, and casting variables. I have set up, for example, a workflow just to cast some format to the other. You can read from certain services quickly, like Firestore, like it was a disk, but literally it's not a disk. And it comes out of box integration with cloud logging and audit logs. So that's very helpful for your upper management when you need to do some reports on that. So it's automate, orchestrate, provide reliable line of business automation, but also enables kids to build their first serverless product by using YAML language, because they only need to understand how YAML is working, and the deploys are extremely quick to do inside the platforms. For developers, it's easy to build, it scales out, handles errors, and it's auditable, as I mentioned. The possibilities are endless. For developers, it's automating the cloud, shell script replacement, or orchestrating DevOps workflows. For retail, it may have order management or inventory chain operations, also synchronizing systems. For industrial and IoT, you have opportunity to verify equipment lifecycle and workflow-based maintenance needs. So all kind of possible digitalization of internal policies and step engine things. I'm going to switch now over to the IDE to show you how works in real life. I have here the basic example for the Bitly, and I set up in Visual Studio Code task for deploy, execute, and describing the calls, which can be done with the task.json thing. Basically, the command is that gcloud beta workflows deploy and workflow execute, and workflow execute describe last. So if I want to deploy this script, then I'm going to execute deploy, which runs this command. The second line is actually the source of the file, and it's executed, deployed. I need to execute it by clicking execute. It runs the gcloud command, and then I describe to see the results of the service. The results have come back, and it's there, it's a JSON. So this has been shortened. The blog URL is using EMP, but if I want to change, for example, here to be bit.ly, then I'm actually deploying again. The command is here, workflow deploy. It takes a moment to finish. I can immediately execute it. It's workflow execute, and then I can describe it. Execution describe last is a shortcut for this. So you may see here that now the URL is with bit.ly services. People have asked me that the secret is visible here. And let me show you the last example. If I want to code the secret, I can use secret manager. And here I have the first step to define the name of the secret manager, bit.ly API key. The second step to load from secret manager this is the name of my secret and the latest version for it. And the result is written into this variable, but the result is base 64 encoded. So I need another step to actually decode the secret, which is done with base 64 decode and secret response, body payload data. And once this is decoded, the decoded bit.ly secret is in here. So it's extremely simple. And as you see in the 26 lines of code, I have integrated a link shortener. And on top of it, I've used secret manager to actually hide the API key and all this, how it works. Also, you can have automations on Cloud Run. For example, on this example, I have initialize where I have a service named trademark. I then call the API to describe the Cloud Run service. And from the Cloud Run service, I need the URL, which I want to obtain the current URL for the services. So basically, this describes the service, which is extremely developer friendly. It's serverless. And this concludes my talk about presenting you about orchestration and cloud workflows. Greg, are you around?
I am, yeah. I'm here. You can hear me, I'm guessing.
Yeah.
Awesome. Yeah. Thanks so much for sharing that. That was really insightful, and I can see how setting up this type of orchestration would be really, really helpful. Like you say, it's like so many different use cases for how that could help out either developers or different types of organizations with different focuses in terms of industries. We did have a couple of questions, and I want to just take a second for those. You mentioned that that the orchestration is enterprise ready. And of course, a lot of enterprises use Azure or use other clouds. Is it possible to orchestrate Azure hosted VMs as well? Or is there any integration with Microsoft for authentication, for example?
So the system works with inbound authentication for Google Cloud platforms. For anything else which is outside of the cloud platform, you need to add the couple of type of authentications. And in my example, if you have seen that in the bit.ly example, I have the OAuth authorization, and I implemented that. So I would say that not only Azure, but any kind of API service, API endpoint who is OAuth ready or OAuth defined, it can be automated with the step engine.
Wow. That makes it pretty extensible for just consuming other services and still managing your authentication in one spot versus trying to manage it from somewhere else. Oh, that's cool.
Indeed. Yeah, indeed.
Yeah. And is this something that you've built into some of the day-to-day on stuff that you work on? Are you using this day-to-day yourself?
So we are using right now this day-to-day, and I constantly add myself as a developer or kind of automations that I find. It's relatively new products, so we are exploring as well. Currently, I have been asked that how many things we have in production right now. We have more than 400 engine definitions in the cloud on various products. most of them are for automating different services and actually connecting 2 or 3 steps with the engine.
Wow, yeah, that's a lot of services to orchestrate between. Well, thank you so much, Martin. We really appreciate all of this. This has been super enlightening, and I think everyone is pretty excited, if I had to guess, to start using orchestration within their GCP workflows. And yeah, it seems like something that is a great answer to the question of building the pipelines of the future, which I think we'll see orchestration of these cloud services just go higher and higher, and it impacts just every side of it. So thank you so much for joining us, Martin, and taking the time out today. And yeah, we're super happy to hear from you and gain from your expertise. I just wanted to mention as well. Oh, sorry. Go ahead. Go ahead.
Thank you for being here.
Yeah, thank you. I wanted to mention as well that Martin is a Google developer expert, and Kyle Paul will be speaking at 1 p.m. about what it takes to become a Google developer expert in Stream 2. So if you're interested in becoming a Google developer expert, we of course would love to hear from you. And Kyle actually is in North America, one of the primary points of contact for that. Kyle spoke this morning for a few minutes. And of course, remember that you can get into Stream 2 via go.devfestab.com/experts. So that is the Experts Lounge. Again, that's go.devfestab.com/experts. And so, yeah, thanks a lot, Martin. And we really appreciate having you today. I hope you have a great afternoon.
Thank you. Bye. Thank
you. So up next, folks, we will be hearing from Nan Zhang and Thomas Chan. I'm super excited about this. We'll kick that off at 12:20, and so we'll be back in about 10 minutes to learn about dealing with ever-changing cloud security landscape. I'm happy to be speaking with them because I work with them all day long, every day in my day job. So looking forward to that. So I'll see you in about 10 minutes. Thanks so much.
Mind's been floating a million miles from home. Head in the clouds, I've forgotten how I'm left alone. Oh, been chasing dreams since I was young. I never stop. Oh, if I fail, I will get back up. I get what I want. 'Cause I see you in my shoes, standing where I'm meant to be. Got everything, nothing to lose, so I keep living my dream. I'll hold the ropes, I won't give up. Our time is now, it's at my luck, it's at my luck. Oh, it's at my luck. better days are waiting here for you. My roots run deep and nothing's been wasted. It's up to you. Oh, it's part of me. It's all I need. It's all I got. Oh, so I will fight until the end of time for what is mine.
Have a good day?
I did. How's your day?
It was good.
We love to watch cooking shows together.
All the time.
And sometimes we'll get inspired to actually try the dishes ourselves.
You texted me shepherd's pie?
Yeah. Have you ever had it?
I have not.
And you're like, Ma, how do they make this?
Hey Google, find a recipe for shepherd's pie.
Okay, I got a recipe called shepherd's pie from Food Network. Does that sound good?
Yes.
First step, peel the potatoes and cut into 1/2 inch diced.
The onions are like... hey Google, order more paper towels. The best music to cook to, you go with like...
I really love listening to the 90s.
All right, check out this 90s hit song station on YouTube Music.
Hey Google, what's the next ingredient?
1/2 cup cream. For a lighter version, substitute vegetable or chicken broth.
Hey Google, pause music. Wait, you're putting it in there?
Yes. Right?
Wait, that can't be right.
Hey Google, repeat previous step.
Cover and simmer slowly.
It's helpful to be able to go back so that Google can prove me right.
Yeah, but once the potatoes are in?
Yep. Hey Google, set a timer for 5 minutes.
Okay, 5 minutes, starting now.
Having multiple timers? Hey Google, set a pie timer for 25 minutes.
Second timer for 25 minutes.
Game changer. Hey Google, call mom.
Calling mom.
Hello.
Hi mom, it's Jesse and I'm on with Steph.
Hi, kids.
We're making a shepherd's pie.
I'm sure that she did all the work.
She knows. She knows. She knows. Cheers.
Hey Google, give me some applause.
Welcome to Get Cooking in Cloud, where we share the best recipes to apply in your cloud kitchen. I am Priyanka.
And I'm Jenny, and in this episode, we'll be making a loaf of gluten-free bread.
Yes, we will. There's a lot going on in this recipe that we will need to pay attention to, keeping ingredients separate from the allergens, keeping ingredients separate from each other, and making sure our space is allergen-free.
Much like with cloud security, we need to keep things safe from external threats and even from mixing internally before it's appropriate.
Dinner Winner is an application that collects recipe submissions from users all over the world and posts regular winning recipes for everyone to enjoy.
The recipe submissions need to be assessed for clarity and then scrubbed for any identifiable information before they are sent on to judging.
The anonymous judging takes place, after which winners are contacted and their recipes are posted to the application.
Submitted recipes can't mix with reviewed recipes due to the potential private information from contestants, so it's critical to uphold that separation. Just like with creating gluten-free recipes, it's important to not only have gluten-free ingredients, but a gluten-free space as well.
Exactly. Our recipe is simple, but this situation is complicated. And for Dinner Winner, due to the high number of submission, that's a lot to handle.
Do we need a dedicated facility or just a strict cleaning policy?
Well, it depends. Let's see how their system works today. During the competition times, users upload their recipe in the text format. These recipes get stored in blob storage, from where they're pretty manually checked for private information like emails and phone numbers of participants. This private information is then removed before sending to the judges to vote. The winning recipe then makes it on the platform for everyone to see.
The problem with it, well, there's a lot of problems with this arrangement. One, because this is a manual process with a ton of volume, this system will scale badly. But the biggest problem here is security. It's difficult to know what's been reviewed and what's been updated and what still has private information in it.
What if just one recipe submission gets accidentally shared with the judges with the contestant's name and contact information? This will potentially make the contest unfair and can lead to brand damage for Dinner Winner, which sounds like a losing situation.
And since Dinner Loser doesn't have the same ring to it, let's make sure they can keep their recipes clean of personal information just as we need to keep this surface clean of gluten.
Just like Dinner Winner, in every organization, data protection officers like you face an ever-increasing amount of data that must be protected and treated appropriately. Quarantining and classifying that data can be complicated and time-consuming, especially given hundreds or thousands of files a day.
And what if you could take each file, upload it to a quarantine location, and have it automatically classified and then moved to the appropriate location based on the classification result?
In the next few episodes, we will show you how to implement such a system by using Cloud Functions, Cloud Storage, and the Cloud Data Loss Prevention API.
Dinner Winner needs an automated process for sorting submissions and categorizing reviewed submissions.
The ingredients: App Engine for front-end, Google Cloud Storage to store recipe submission files, PubSub for messaging, Cloud Functions for some quick automation in serverless fashion,
and the most important ingredient, DLP API to detect private information.
Now, let's put this all together and stir it up. Let's say the front end is an app engine, where the user submits the recipe. The user would upload the text file, including the recipe and info types like the name, date, email, and phone numbers in the web interface. The uploaded file is sent to Google Cloud Storage. This triggers a Cloud Function to create the data loss prevention job in PubSub.
Once the event is received by PubSub, it triggers another Cloud Function which calls the DLP API and looks for the confidential information in the recipe files. Once found, it moves the file to a separate storage bucket. If the file does not contain any confidential information like the info type's email, address, phone number, then the function moves it to another bucket. This request flow keeps the confidential data separate from the non-confidential and is fairly automated, such that as soon as the file hits the cloud storage bucket, all other processes kick off automatically to protect the data.
Now that we understand the problem and the use case, we know exactly what needs to be done to implement this solution.
And next week, we'll reveal our step-by-step plan for Dinner Winner, and maybe we'll even get to that gluten-free bread.
Yeah, but first, we will need to avoid cross-contamination by deep cleaning the kitchen.
And since Git cleaning with cloud isn't quite what we're going for, we've got some behind-the-scenes work to do.
While we're at it, don't forget to give us a like, comment, and subscribe to learn what you can cook up with the cloud.
Hi, I'm Stephanie Wong, and I work for Google Cloud. While I could talk all day about cloud security, physical security at a Google data center is still pretty new to me. So today, I'm on a mission to learn all about it by taking an inside look at the systems in place that protect customer data at a typical Google data center. Let's go.
Now, I've been told there are 6 layers of security here. Security layer 1 refers to the property boundaries, and that includes signage and fencing. But things really start to get interesting when it comes to layer 2, also known as the secure perimeter. And that includes the main entrance gate, which I am pulling up to right now. Hey, how's it going?
Good morning.
So layer 2 has a lot of security features, ranging from smart fencing to overlapping cameras to 24/7 guard patrols and more. I'm on my way to meet some experts who are going to show me how it all works. Hi, Joe.
Hi, Stephanie. How are you?
So I just passed the main gate and I saw guards and cameras, but what are some things that I didn't see?
Yeah, there's actually a lot of technology and operations going on behind the scene. So from the time that you're on site, we know that you're here and we're able to do correlation analysis of where you've been. We have guards in vehicles. We have some guards on foot. There's also the vehicle crash barrier. That's designed to stop a fully loaded truck from crashing through the front entrance.
Ricky, Tariq, can you tell me more about what's unique about the fencing?
This particular fence is an anti-climb fence. It's also equipped with fiber. The technology tells us if someone's near the fence or touches the fence.
So we use thermal cameras and standard cameras, so we're able to see video footage at night just as clearly as we can during the day.
Welcome to Layer 3, Building Access. But just so you know, I am still nowhere near the data center floor. That's a few more layers deep. Let's head inside.
Stephanie, so you've gotten through the gate, you've come into our secure lobby.
You have your card, and we know that that's you, but if someone happened to lose their card, what we want to make sure is that it's actually Stephanie who's shown up.
Place into your eyes.
And with iris scan, we can authenticate that it's actually you along with your ID.
All right, I think it's good. One thing that's a little hard to get used to when you visit a data center is for secure areas, only one person is allowed to batch through a door at a time. Layer 4 includes the Security Operations Center, or SOC, a hive of activity that is monitoring the data center 24/7, 365 days a year.
So it sounds like we've been keeping them very busy today.
Yes, you have. So the doors, the cameras, the badge readers, the iris scan, everything is connected here. This is the brains of the security system. So if there's anything out of the ordinary happening, they have to be able to pick that up.
Interesting fact about Layer 5, the data center floor. Less than 1% of Googlers ever get to set foot in here. So right now, I'm feeling kind of special.
This is truly a as-needed only access area, meaning that only the technicians and engineers that have to be there to maintain, upgrade, or repair the equipment are ever allowed there.
And do Googlers or anyone have access to the data?
We have access to the devices, but the data at rest is encrypted, and our customers can issue and keep their own encryption keys. And we do this because protecting the privacy and the security of our users' data is our highest priority.
The mysterious Layer 6, where disks are erased and destroyed, and the fewest number of people are allowed to enter. Drives that need to be retired from the data center floor come into this room through a secure two-way locker system, which means that only technicians assigned to this room can pull them from that locker to either erase or destroy them.
All right, welcome to the Crusher Room.
Wow.
So at this point, we have scanned the hard drive and the software has told us that we need to destroy it.
Can we see it in action?
Back up.
All right, I'll stay back here. That disk is definitely destroyed.
Yes,
it is. If you didn't think these 6 layers of security were enough, Google Cloud actually has 2 security testing programs in place. One hires companies to try to break into data center sites from the outside, and the other tasks Googlers with trying to break security protocols from the inside. And getting out of a data center is arguably even harder than getting in, as everybody has to go through full metal detection each time they leave the data center floor. Google Cloud supports compliance with over 40 global standards, regulations, and certifications. And the commitment to constantly test, optimize, and improve systems makes it a leader in data center security. Now, how do I get out of here?
Welcome back to DevFest Alberta. Again, we're streaming live from my spare bedroom. We are going to be joined right now. We hope you took a few minutes to stretch your legs and get up and down and learn how to cook with Google. So we hope you enjoyed that. We are joined now with Nan Zhang and Thomas Chan from Source Group, and we are super, super lucky to have them because in my opinion, they are, and not only my opinion, but verifiably, they are some of the top experts on Google Cloud Platform security anywhere in the world, and I am lucky enough to work with them day to day. So welcome, Nan and Thomas.
Thanks, Greg.
Thank you. Yeah, glad to have you here. So maybe if you want to talk through just a quick intro about yourselves. I know that, so I work with you day to day with the bank that I work for. Yeah, so how did you guys get into this GCP security game?
Yep, so for sure, we actually do have a introduction, but I guess we'll just skip that.
Sure.
Yeah, so I was probably one of the earliest consultants that worked with the GCP platform, especially in banking industry a few years ago. We built a couple platforms for one of the large banks here in Canada, as well as one in Australia. And then just got to know the Google team, the platform, fell in love with it. Yeah, basically was able to just get into the game early enough, I think. Yeah, and then I just saw how the platform has grown in the past 3-4 years in front of my eyes. Was really good, great to see. Like additional features were added every other week. That was useful for automation deployments, for GKE, for security. And yeah, it's been getting to a really complete platform by now.
Yeah, absolutely. I would agree with you. And things are starting. You can definitely see that maturation over the last little while. And so, yeah, Thomas, how would you get into things?
Yeah, name's Thomas. I'm consultant with Source Group as well. I spent most of my career in a lot of heavily regulated industries like insurance and healthcare and financial institutions. I started my career doing a lot of full stack dev and engineering, and when cloud came, I got all gung-ho about cloud architecture, so I got into that as well, and just kind of naturally moved towards DevOps because, yeah, I've been in that space where we did a lot of manual deployments and the headaches that came in. So when cloud came and all this automation came along, it's like it just naturally fit for me, and just sort of developed a passion for engineering and all things cloud native. So here we are. Yeah.
Awesome. Well, we're super happy to have you, and I'll let you guys go ahead with your presentation. I'm really excited to see your demo, and so yeah, everyone should be looking forward to that. And yeah, so I'll let you guys run.
Yeah, thanks so much, Greg.
Thank
you. Yep. So yes, good afternoon, everyone. So hopefully you guys are having a great Saturday, staying safe and happy. So today we'll just be talking about a few methodologies that we're using with our clients on how to deal with the ever-changing landscape of public cloud security. Like I was just mentioning, public cloud is changing really, really fast. On average, there are 9 pushes to a platform, either GCP, AWS, or Azure a day. And then it's really hard to stay on top of your game if you don't have the proper principles and controls. So today we'll probably be starting talking about those. So just as a brief introduction, as you already heard, my name's Nan. Tommy, if you want to go next. My name is Nan. I've been working with Source for about 4 years. And for today, we'll be going over security and cloud principles that we think are rather important, some samples. We're going to be talking about preventative control, detective control, which are 2 control methodologies that we use in our day-to-day lives, as well as a quick demo on Furet validator. And Tom, yeah, so the company was founded in 2010 in Sydney, Australia. So it was a small group of people that then naturally expanded to Canada because there was some Canadian connection. So we now have 3 regions within the world. One here in Toronto, which is our headquarters. So that's where me and Tom are located. And then we have another office in Sydney, Melbourne, Singapore, Malaysia. So we are focused on security, as well as automation and cloud transformation for large financial institutes. We have a vertical in public sector, in aviation, which has been hit hard this year. as well as media and healthcare. We are, I believe, the only headquartered consulting shop in the world that in Canada that has the 3 top-tier partnership with the hypercloud providers. So AWS, Azure, and GCP, we're all of a top-tier partner. And we have a bunch of specializations as well. So for today, I'll be starting with security and cloud principles. Tom, next. So why do we actually have to talk about cloud principles when we talk about security? Well, if you think about it, right, security opinions have to be derived from somewhere. Your security team won't just come and say, you know what, I think you should do this. They need to provide concrete evidence as well as on how to on guidances to help the platform to become more secure. If you go next. And I do want to apologize. We thought we're going to present, each of us was going to present, but turns out we can only have one presenters. That's why Tom is presenting. I have to tell him to go next. So the security, the cloud principles themselves enable organization to be successful, right? This includes building platform application agility through automation, standardization. Those are one of the main principles that we follow. Another is to not risk the cloud provider. So basically leverage all the features, all the 9 pushes a day from cloud providers themselves at the same exponential pace that we do as part of the platform. As well as collaborating with your risk team, your compliance team, your infrastructure team, and developer team to gap the silo that we've all known and seen in our day-to-days to bring them all together. Just to give you some sample principles, next. So just when you talk about, for example, data, right? So cloud principles in data would include something like all data stored in cloud should be encrypted at rest. When you transfer the data over, it should be encrypted in transit. You should always have a multi-layer security control around your data to prevent any data exfiltration. For a cloud principle around IAM, it's the one that we are all known for. So basically, you have to follow principle of least privileged, and then no user should have day-to-day access to your non-prod and prod environment. From your deployment side of things, that we believe a cloud principle for deployment would be that you should always be doing Git-driven deployments and no manual access to console. This may be a change for some of you, but we believe it actually really helps guide your security operation opinions, and I'll be explaining that in a bit. We also do think that all deployments to non-production and production should be peer reviewed via your GitOps approach. So if you're trying to change a production level system, it should be reviewed as part of a code review. It should be reviewed as part of a change ticket, and only gets pushed to production when your peers thinks there's no problem with it. And there should always be an adequate level of testing as well. So based on these principles, we then move on to controls. Next, Tom. So yeah, so we talk about controls, and there are usually 2 types of controls that we're really used to. One is called preventative control, and the other is called detective control. Just to give you a real life example that's actually happening right now, because I can hear it. Like, it's me telling my daughter that you're not gonna watch more YouTube, right? I'm gonna go into the router, find your MAC address, and just kill that. It has happened before. Right? That's a preventative control. So when she opens her Mac tablet, she wouldn't be able to access YouTube, which she's doing right now because I'm doing this presentation. Another way of a control, detective control, is me and my wife are both working. It's 6 p.m. and she's my daughter's home downstairs, and my wife went to get some water, and she's like, "Oh, you know what? She's watching YouTube because she finally figured out how to press the YouTube button on your TV," and then she somehow got into Paw Patrol. Right, so that's me, my wife telling me that she's detected something that's going on in my household, and I have to do something about it. So yeah, so I'll be going through the preventative control side of things, where Tom will be talking about detective control. So preventative control, if you just go next slide, has to start with a strong, what I call a foundation pyramid, right? You have to be able to enforce certain things. For example, you're not going to have manual access to your non-prod and prod environments. On top of that, all your deployments are happening with infrastructure as code and GitOps pipeline. And on top of that is where most of my content is going to be around consumables. So what is a consumable? Consumable is actually a piece of infrastructure as code package. It can be in Terraform, it can be in Azure ARM, it can be in Deployment Manager or CloudFormation, or anything you want. You can write your own APIs. But this is a collective opinion that that's get packaged together and gets consumed by other people. As an example of a GCS bucket, your application team is going to come and say, you know what, we have an opinion around GCS. We want our GCS buckets to be regional redundant. So if a flood happens in US East, my bucket is still alive because my data is in US West as well. Or security will come and say, you know what, no bucket should be publicly accessible. Yeah, pretty straightforward. Where infrastructure opinion will come and say, you know what, all GCS buckets should have version enabled. It helps us manage and roll back if there's something wrong. And you can have more opinions around this, right? Your compliance could come and say, you know what, all data access logs should be enabled by default, where your networking team will be like, oh, you know what, we need to be drawing out networking parameters to protect our GCS bucket. So you merge all these opinions together and it forms a GCS consumable. This also really helps, this helps really bring the teams together as well, when you think about it, right? There's maybe 25 to 30 common resources that your application team is going to consume in cloud, maybe even less. And when you talk about each of them with all the teams around, your security team, your infrastructure team, and your application team, right? You can bring their opinions together. Everyone gets a better understanding of how they're consuming cloud in general. This also helps misconfiguration of tools. So if you go to the next slide, and basically a screenshot I took a couple of days ago, these are all, not all actually, maybe 80%, maybe 90% of the options that you're using to create a GKE cluster in the GCP console. There are about 45 different options here, right? So for any individual to come and see, you know what, I want to create a GKE cluster. Here are the 45 different things I may want to think about. It's going to be a very daunting task. Your security team may also have an opinion around, like, you know what, we should always be enabling workload identity. We should always enable private cluster, where your networking team will be like, you know what, I need to protect my GKE master, so no outside resources can hit it. And if there's a bug, I may be getting hacked. Your developer team may have an opinion. I want Istio, or I want TPUs because I'm doing kubeflow. But they may not have the opinions around security, right? And your DevOps team may have opinions around automation. So, you know, we want to hook up maintenance windows as well as build pipelines to our GKE clusters automatically. So if you have someone configure this yourself, you're going to misconfigure 90% of the time, because either they don't have the knowledge or they just don't want to know, right? Where if you think about getting all these opinions packaged together and just send it as a module, a Terraform module, a deployment manager module, and say, you know what, here are the 3 things we allow you to change. You can change the cluster name, size, and if you want a Istio or TPU, right? Your developer will be able to say, you know what, that's simple enough. I can say, I can configure these 4 things, while all the security opinions, operation opinions, networking opinions are all taken care of. So, and we do recommend when you do this kind of consumables, you start from day 0. So when you build this whole thing, right, if you go to the next Tom, you're preventing any configuration drift in day 0. You don't want to just give people access to be able to go click on things, and 11 months later, you're like, we've left with 45 GKE clusters. That's all configured differently. But if you push those consumables concept out in day 0, you're going to be able to get people to understand it, use it, give you opinions, bring the teams together. And you know what? Getting the standard one is actually the simplest for them. So we do recommend the consumables model since day 0. If you go next, also, GKE is just an example, GCS as an example. You can then potentially build a library of all consumables, right? Which I call primitive consumables. You have opinions around your virtual machines, your GKE clusters, your Redis, your Cloud SQL databases, your storage buckets. These are primitives. These primitives can be distributed to teams, when they have a specific need, when they spin up some resources, they will just get opinions of these primitives themselves. And when they are used to the model, they can even start building patterns themselves that can be feedback into the platform team. So for example, if a team is always going to be using a GK cluster with the Cloud SQL backend, and then they have a Redis for caching purposes for the session cache, and have a GK have a global load balancer and Cloud Armor in front, and you're seeing this as a pattern within your organization, you can just package these infrastructures code together as what I call an application consumable. So at that point, you have an application consumable you can just distribute to other teams saying, you know what, this is a standard architecture within our environment. If you're consuming GKE, we recommend a Redis for your session data. We recommend Cloud SQL. And here are the 8 options that you can configure in order for you to get the full stack infrastructure up and running. The more you build, the less other people have to worry about. You became a fast-paced moving organization with many standard pieces of infrastructure that can be reused across different teams. So what are preventative controls good for? Thinking about day 0, right? When you start your cloud journey, your preventative control would probably be good for any core infrastructure. So if you're creating a project, you're doing IAMs, you're doing your account service principals or service accounts, you're doing your VPCs, you're doing your DNS or organization policies. What we recommend is that these will always stick to preventative control because these gets barely touched, right? It's a low effort to maintain, but you get a lot of value in audit as well as review capabilities. When you move on to application infrastructure, it's still recommended to start with preventative control because, as I said, it helps with misconfigurations. It gets to an understanding for developers to know exactly what they're consuming. And then they don't have to worry about many of other components that they may not be knowledgeable for. So yeah, so we do believe that you should always retain a preventative control framework for your core infrastructure, and while potentially moving your application infrastructure to a different control later on. Let's go next. Just go next. So yeah, the one outside of the preventative control, there's also baseline. It's IAM, right? IAM is actually what prevents people from doing things that you don't want them to do. So it doesn't matter if you're using AWS, Google, or Azure. IAM is your crown jewel of a platform. You should always be controlling who can do what where. That way you can have effective controls for your platform build out. And at this point, I'll be handing this to Tom for explanation of detector controls.
Thanks, man. That was informative. So detector controls, what are detector controls? So up until now, we've been talking about preventive controls, which I like to call freedom without guardrails. Detective controls, on the other hand, is freedom without the guardrails, but with parental supervision, so to speak. Its duty is not to obstruct, its duty is to inform and correct where it can. So it's not supposed to stop you from doing what you should be doing, but if you do those things, it will find out about them, it will tell you about them, and apply corrective action where necessary. So anybody who's familiar with Liam Neeson's works, sort of like what he does. So we've talked about preventing resources from being deployed based on a set of security policies in place. What about resources that are already deployed and live? What if security policies change? Or even what if an administrator applies a firewall change that they shouldn't be doing accidentally? These are all examples of where detective controls are necessary to complement your security controls. A more peripheral reason that not a lot of security teams are thinking about is about upskilling your organization, right? So preventive controls with guardrails can be sometimes quite restricting, right? You're not only stopping your team from doing things, but at times you might be stopping them from learning. So the last thing we want to do is slow down your teams. That's kind of where preventive controls in an organization, as they mature in their cloud journey, should give rise to more detective controls over time. So over here we have a graph of kind of the natural progression of some of the most successful organizations when they start their cloud journey. Initially, they want to have preventive controls in place just to kind of guide them and set them straight before moving to more detective control based measure as they mature in the cloud. Right. So preventive controls are a powerful set of security tools, and it's important that we implement preventive measures early on in an org's cloud journey to shape their cloud foundation and lock down suspect behavior. And Nan's touched on about this earlier. But we've all been at organizations where too much restriction may start to impede productivity, innovation, and the rate at which your cloud team upskills. So we start to turn into that overbearing parent. So it's important as our organization matures that we start to kind of peel back this bubble wrap off as teams want to start to accelerate and move faster. So how do we do that? We can start to loosen restrictions on preventative controls and resources and allow teams to be autonomous and replace these preventative controls with more detective-based measures. But the question becomes, then what do we loosen these restrictions on? How do we choose which resources? So that's what we call the line, right? And Nan has touched upon this earlier. There's a set of core infrastructure that you kind of always want to have preventive controls in place. These are resources that your application teams don't really interact with on a day-to-day basis. They might maybe make some requests now and then to gain some more access, that sort of thing. But things like your project structure, shared VPCs, your network design, service accounts, things like that, they're not really interacted with from your application team on a day-to-day. So we kind of want to have that preventive control measure in place always for your core infrastructure. Then there's your application infrastructure that your application teams do interact with every day. And instead of having us tell them what they can and can't do, we kind of, as they mature, as the organization matures, you kind of want to let them experiment, let them start using these and start learning, right? So that's kind of where we want to loosen some of these preventative measures in some of these consumables that we've mentioned earlier. Now, when I say loosen, we're not saying get rid of the controls. We're merely saying they should come in a form of more detective-based measure where you're not stopping them from making these mistakes, but then you can detect it and you can remediate it, and that's what detective controls are. So over here is a sort of an overview of some of the detective control solutions available that you can leverage in public cloud today. This isn't by any means an exhaustive list of solutions available today. I mean, AWS has quite a bit of names that I can't even remember, but we are focusing on this in this talk about more customizable policy-based threat detection. So specifically for SETI in GCP. So what is Forseti? Forseti is just it's an individual 3-tier app that you can spin up in any project. It just works like a 3-tier app with a client server and a SQL database. It scans your resources based on a snapshot of your asset inventory, which you can generate in any project. Oh, my Siri just went off. And based on those resources that it scans, it can notify and alert and remediate any violations that your resource states are in violation of. So what does that look like from an architecture perspective? Well, Forseti actually contains about 5 main parts. There's the inventory, which essentially is what I mentioned before. It's just a snapshot of your assets within your project, and it's just comes in a form as a JSON file. It's a JSON dump of all of your resources in your project, along with a lot of the metadata with it. It stores this as a snapshot in your backend SQL database. Now, in this particular architecture, we're using Cloud SQL, but it doesn't have to be Cloud SQL. It can be any sort of SQL relational database that you choose. It consists of a scanner, which scans your asset inventory against policies that you've defined and will alert you of any violations using the notifier plugin. That notifier plugin is essentially just another component which allows you to send notifications to a number of different third-party applications like Slack, or to a GCS bucket, or to Security Command Center, which essentially is another GCP product that allows you to aggregate a lot of your security findings, and of course emails as well. There's an explainer component, which essentially is just information on the violations that come back from your scanner and explains what those are. And of course, your enforcer component, which, should you choose to configure it that way, will remediate any findings by setting things that are different from your desired state and sets them back to your desired state. Your things are in conflict. So up until now, we've been talking about preventative and detective controls as two separate concepts in your toolbox to manage security. In the previous example, suppose I wanted to set up a network APC and not allow SSH out to the internet. Now, I could either set it. Sounds like I need to set it up at both your detective control framework and your preventative control framework. Sounds like I need to do it twice, which sounds like a lot of overhead. Do I need to do that? And the answer is no. We can actually use what's called config validators, which is part of your Forseti toolbox, to combine both preventative and detective controls in one place. Sort of a one tool that does both. So how does this work? We need not define policies twice. We can define Forseti constraints, what Forseti calls constraints, which are just a YAML configuration file that if a lot of you who use Kubernetes and Open Policy Agent would be familiar with the format of this. And they can be defined once in a centrally located organization repo. And Forseti comes with a config validator, and Terraform comes with a Terraform validator, which both consume this centrally located policy defined in Rego, and essentially validate the same outcomes. So what does this look like from an operations workflow perspective? We have a security admin that can pull down constraint templates from a Forseti security library. And this Forseti security library is an open source repo contributed by the community that you can take down and store in your own central repo in either an Artifactory or your own repos, internal repos, and customize to your own security posture. They can modify these templates as needed, and basically that is managed by that might be managed by your security architects. Then you have your Terraform validator, which traditionally would be your DevOps teams that control your CI/CD pipelines and are in charge of deploying things like your GCP resources. And this Terraform validator will consume and pull the policies from your centrally managed repo and validate your Terraform plans before actually deploying them to your GCP environment. And of course, your SecOps teams in charge of ongoing policy enforcement will get notifications and direction to remediate potential security threats in any live running environments should the state of resources deviate from your desired state. And they're just reading from the exact same centrally defined repo. So, quick demo. As I mentioned before, the config validators actually consist of three parts. There's your policy library, and this is again where your security architects would check out from and actually manage their own sort of customized repo. This is where they would be defining their own policies and constraints. You have your config validator for Forseti, which will consume those same policies, as well as your Terraform validator, which also consume those policies as well. So what this looks like is then I have a simple deployment here of a Terraform template that just deploys a simple compute instance in GCP, and of course an access config that deploys, that gives an external IP. And then I have my policy library. This is where your policies reside, which contain your constraints and your templates, and I'll go over in a sec what that is. And I can show you in real time how this actually works. So the first thing I would do if I want to deploy this, first create a Terraform plan. And it's created my plan here, over here. Now the Terraform validator actually works by validating against the JSON version of your Terraform plan. So I would be creating a Terraform JSON format of the Terraform plan over here. And I've downloaded my Terraform validator here, which is just the compiled binary of the Terraform validator. Terraform validator is written in Go. So essentially you can compile it and modify it as you please. And it just runs off of a Go binary. So I can run that. So what's happening now is that it's actually going into my policy library, which I've defined as a path and as an environment variable. So if I look at my policies, there's constraints and templates. So what are constraints and templates? Templates are essentially just the predefined templates that or packages that the community has already written to in Rego, and they're essentially policies to validate certain GCP resources. So people who are used to Kubernetes will find this very familiar. And in line of it is actually the actual Rego code that defines the actual policy to validate it against. So and then there's constraints, which essentially are the actual constraints that your validator will validate it against, and will actually use these templates and supply the necessary properties to validate against. So for example, there's an external IP access one for compute. It takes in parameters such as mode and instances, and you can configure it to work either as a blacklist or a whitelist, and we'll validate accordingly. So I don't have any constraints defined at the moment. So while this is running, it should come back with no violations. So essentially, anything you put in this constraints folder are the actual live constraints that it's going to be validating against. So yep, no violations found. So now I've got a pre-written constraint here. If I just put it back into the folder. And essentially all I'm saying is let's use the template that doesn't allow any external IPs. And I've given it a whitelist, an empty whitelist. So if I run this validator again, it's going to again go through my policies and templates, read them all in, find the actual constraints, and validate accordingly. Now I'm showing you what's under the hood. Ideally, what you want is this to be running in an actual pipeline, a Terraform pipeline. So in the previous example, when it finds no violations, that's when you would pass the build and actually do the deployment. In this case, I've added a policy where I'm not allowing external IPs. So if it fails, finds any violations, that's when you would fail the build and stop the deployment. So this would show you sort of your preventative control side of things. Similarly, there's the Foret side. Now I don't have, time's not allotted to actually show you the whole Foret side of things, but it works in a similar fashion where it's validating your asset inventory. And I do have an example of what your asset inventory sort of looks like. And it's sort of a JSON dump of all of your resources in your GCP project, and along with all the metadata that goes along with it. So when you download your Foret config validator, it essentially allows it to validate your Forseti resources against Rego code in your policy library. So again, so here it's finished validating my template. It's found the constraint. At this point, this is where you would fail your pipeline. And that's sort of how you can see how one policy defined in one centrally located area can control both your deployment pipelines as well as your detective controls in Forseti. So continuing on, if you want to learn more about how some of these policies and kind of play around with policies, I do have some links here. Feel free to screenshot it and yeah, take it away.
Yep, and we've also, our company has also just spun up a different entity called Kibera that will be doing a multi-cloud preventative control for you. So if you were interested, take a look at kibera.io. It's not in a product phase yet, it's just in under testing, but it's quite interesting. I've seen a couple of demos. If you ever do want to just learn about how our journey of GCP is, there is a white paper to your top right. Go take a look at that, and also any security assessment that you potentially need help with, just like how Greg is doing with us beginning of the year, be coming to us via that link as well. And lastly, follow us on our LinkedIn if you are looking for opportunities, or if you want to just chat with us, connect with us. We're just a bunch of techies located in Canada, Australia, Singapore. We speak a lot of different languages as well, so just connect with us. And any questions will be open to take now.
Thank you.
Greg, you're muted if you're talking.
I was muted and I am talking. Fantastic. Yeah, I really appreciate you taking the time to walk through that. That was a bunch of knowledge bombs all over the place. We did have a couple of questions. I think we could probably take 1 or 2 minutes of questions. And so one of the questions was, so Forseti can automatically generate an IoT asset list and apply policies accordingly?
It depends on the IoT access. So if our IoT access has been configured as a GCP resource, yes. Because Forseti takes the entire GCP environment, everything within your GCP, and then you can write your own policies as well in Rego. If you've ever done any open policy agents, OPA, Gatekeeper with CNCF, the policies are the exact same syntax. You just have to write it yourself. Yeah, I wouldn't be surprised if there's also open source capabilities already around.
Yeah,
if it generates resources and it generates metadata, you could write Rego to actually validate against it.
Yeah, no, that makes sense. And I mean, it's nice to have that sort of asset list that you can then, just right up front, that just makes it a lot easier to then start considering what you could use it for once you can see all the assets that are in the environment. Let's just say, I mean, most people that I know of haven't got into using Forseti. How would someone start that sort of process? What would you recommend?
Yeah, so Forseti, like Thomas said, it's just a 2x2/3 tier application. It's super simple to set up. You just have to create a project within your GCP. There is a Terraform module for Forseti. Go to their website, forsetisecurity.com, and you'll be able to just find instruction on running the Terraform module, which will set up all the components with you. But in mind that you do need to give permissions to yourself in order to bring those resources up, as always.
Yeah, absolutely. Of course, it's super powerful, so you want to make sure that you're careful with the permissions that you granted as you work through things. So yeah, that's great. There are a couple other questions on the YouTube live stream, but we'll have to sort of answer those in stream. But yeah, thank you very much, guys, for joining us today and spending some time with the community. And thank you for talking about the important concepts here. It's been fantastic working with you guys the last 6 months, and I've personally learned a ton just from the conversations that we've had. So thanks so much again for sort of condensing it all down into one sort of tight conversation. This is like, honestly, 6 months worth of learning sort of in an hour. That's what I know about it anyway. Yeah, basically everything that we've been talking about for months and months and months, it's all right here. So it's fantastic. Thanks for doing that.
Thank you, Greg. Thank you for the opportunity.
Yeah, absolutely.
Happy to be here. Thanks for the opportunity.
And we'll get you back for DevFest next year too. Hopefully it'll be in person.
Oh, yeah, looking forward to that.
Absolutely. So if you're still on the live stream, thanks everybody for joining us. We do have some prizes to be won. So if you go to go.devfestab.com/win and enter to win a prize, we'll do a draw this afternoon about, I think it'll be about 1 o'clock, and we'll get that sorted out. But yeah, if you want to win a prize, we have a few prizes for people that are on the live stream or in the experts lounge. Sorry, was that? Okay, well, we are about ready to wrap it up here, and we will be back with Jay Krish right after this. And he will be speaking about automating Kubernetes deployment pipelines for Google Kubernetes Engine in 10 minutes or less, even though his discussion is an hour long. So we'll see you back in about 5 or 10 minutes, and we'll be up and running as soon as we've turned it back around. Thanks, everybody.
Like you, be strong to hold the powers of the sun. To dream, believe in strength. Now I'm the only one, only one. I was an ordinary boy until I broke the rules. My life destroyed, a life destroyed. Until I walk awake, scream my mind, I shout, the ground shakes. How much can I take? My mind will break. Will it break? Can I take? Can I be your superhero? Superhero. Can I be your superhero? Superhero. 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 Fly away. It's the first time of today. Today. To dream, believe. You are the strength, you're all I need. Oh, gonna give it a shot. Only one of me to shield you all from the enemy. You're a superhero. You're a superhero. Can I be your superhero? Superhero. 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 Can I be your superhero? I won't let you down, 'cause you know me through and through. When you are around, I see the stars come out for you. If we gon' set this fire, we gonna do it right, yeah. We keep it burning higher. We're gonna light this whole place up. And you know, when I'm with you, I am alive. Alive. You make me feel you all the night. The night. The night. When I'm with you, I am alive, alive. You make me feel you all the night, the night. You pull me in, you make me shine, shine. You make me feel you all the night, the night. Before the sun goes down, I can't help me dreaming now. I hope that I won't wake up. I can't help me dreaming now. I hope that I, before the sun goes down. When I'm with you, I am alive, alive. You make me feel you all the night, the night. You pull me in, you make me shine, shine. You make me feel you all the night, the night. I can't help me dreaming now. I can't help before the sun goes down. You pull me in, you make me shine, shine. You make me feel you all the night, the night. I can't help me. I can't help me.
I can't trust myself, so don't get me started on anybody else. I'm under your spell, always overthinking. Hold on to me tight and pull me out to the deep end. Barely breathing, so unbreakable. Keeping an eye and circling like an animal. You won't let me go. This part of me is waging a war, and it turns out I'm the enemy. I'll never be free. I hear you in the night. It's when you come alive, screaming on the inside. You're inside.
Hello, we're back at DevFestAB and streaming out of Calgary here. We're excited to get our next speaker going. But before we get going with that, I want to make sure that everyone knows that Kyle Fall is also speaking right now. If you are interested in becoming a Google developer expert, he's on until 12:30. You can get that at go.devfestab.com/experts. You can go to Experts Lounge there as well and ask questions about that. So we're super excited to have Jay Krish here. Jay is a longtime community member of GGYYC. He has spoken at DevFestYYC before, as you can see, and some of you may remember him from last year. Jay is always willing to get up and speak and talk about all the many exciting things in Kubernetes. He is an advocate and one of the few people that's been to KubeCon more than once. So Jay, yeah, I'd love to welcome you on stage. Thanks for joining us.
Thanks a lot, Greg. I'm always happy to be part of the community based out of Calgary. Okay, so now I would like to start my presentation. As you have seen, I did the same presentation last year, and I'm Kubernetes per se. Even though lots of changes and upgrades has happened, fundamentally it is the same. And this is just an initial introduction for the people who are like very new to Kubernetes. Kubernetes was a project spun out of Google based on their experience in building and managing software. And this is new way of deploying, maintaining, and scaling workloads, where all these capabilities are by default inbuilt capability for Kubernetes. And most of the whole world is moving towards container and container orchestration using Kubernetes. What problem does Kubernetes solve? See, now the development environment and the QA environment and the pre-prod and the production environment are all different. But then if you can Dockerize your application, then it is like, build once, run anywhere in the same way. So there's a fundamental idea Google have utilized. And Kubernetes has got lots of components, but it's nearly a 5-year-old project. All these build and deployment of Kubernetes is automated now. You need not, start from scratch. And that is why this interesting title that you can build your own Kubernetes Kubernetes cluster, which is hugely complex. In like 10 minutes you can build. It is because Google provides you a pre-built Kubernetes cluster, which you can start consuming in like 10 minutes or less. And it only costs you 10 cents an hour. And the first cluster is free. And then for the subsequent multi-location cluster is only like 10 cents an hour. And the whole idea of Kubernetes is to orchestrate your Docker file, which can be built from the laptop or the desktop or a developer, or built in a remote location, and deployment and orchestration happens on the Kubernetes cluster. And in Kubernetes, you just declare what is the state you want it to be in. Like, I want this Java-based application to run with 5 GB of RAM per pod and with 10 CPU. You just declare how it has to be run. Kubernetes will take care of running it. And there's a huge ecosystem of Kubernetes. And Kubernetes you can run on your laptop or desktop, or in a managed environment on your premises data center, or even in public cloud. And the GKE is a Kubernetes engine which is managed by Google on Google Cloud per se. So now Kubernetes has got multiple capabilities such as auto scalability, self-healing capability, and it manages your jobs, stateless and stateful application, and easily integration with third party. And by default, Kubernetes gives you a rolling update with which your users will not even know that upgrade is happening. Without near zero disruption, you can get your application upgraded. That is one of the default capabilities of Kubernetes. And you can also set up all your declarative Kubernetes configurations in any sort of Git repository, and you can configure Kubernetes to pick up and deploy, so that there is not even any manual deployment needed, or it also can be done in a repeatable way. And there are some fundamental concepts you need to understand, which are like newer in a Kubernetes world, such as a pod, which is your container, which contains your binary or the application, along with the declarative configurations, that is the pod. And then services and volumes you might have already used. And the namespaces is mainly to isolate your application. Like in the same cluster, you can have a dev and a QA and pre-prod and production environment isolated using namespaces. And then you can have labels to select, like you can say upgrade application version to 1.1, where the label equals my Java app. So these are fundamental concepts you need to know to run. And mainly it has got a master and a node component, and all these components are highly available, and there's at least more than one copy of each of these components available. So even if somebody pulls the power cable of one of your master node or a node where the compute node, still your cluster or your application will be up and running. kubectl is the command you use to connect to Kubernetes and consume it. And YAML is the declarative way with which you configure your application. Now, Kubernetes ecosystem, like if you see here, Kubernetes is just one part of lots of other related free and open source software. And you can pick and choose which say proxy, a service mesh you want, API gateway you want, or a service proxy you want, or monitoring systems, platforms. There's lots of other application which sits in and alongside your cluster, and you can use it. And now the demo time. There is 3 ways to create. There's multiple ways to create a Kubernetes engine, but here I'm going to show you 3 ways. First is the manual way, right? So to get into the manual way, I will show you. Let us get in. I have a project which is created. I hope you will all have access. I mean, step 1 is to have access to your Kubernetes cluster from this console. And after this is completed, we will go to step 2, which is creating using Terraform, right? And then at the end, we will go through seeing how from a GitLab CI, because a CI will be CI tool used by each company is going to be unique. Like there is Circle CI, GitHub has got its own CI/CD tools, and GitLabs. I've chosen GitLabs here because this is what a couple of previous of my employers have used, and this is also, I think, one of the mostly used CI tools. Okay, my internet. Now, this, if you go to Kubernetes engine, you can click create cluster. This is manual way of doing it. You need not do it, but I just want to also show you how you can also manually create it. Okay, so now this is very, very simple. Let us say cluster 0, 1 and zonal or regional, and then you can choose the number of pods you need to have. For now, because this is just a test environment, I'm just going to say 1, and it is as simple as creating this, clicking this button, right? And then if you go back to your cluster, you will see this cluster being created. Right, see cluster 0, 1, which I said with 1 node is being created. So this is manual way of doing it. No big deal, very easy. Just to show you how easy it is to create a Kubernetes engine cluster with which you can scale like thousands of nodes. Like you can have hundreds of thousands of containers with thousands of nodes. You can run it on a Kubernetes engine, which has got all these self-healing capabilities, which you can create in like less than 5 minutes from a graphical user interface. As this is being created, now I want to show you the little bit more details about this cluster which is being created. I think it's only my internet is slow today. Otherwise, I've seen this coming back like within a second or two. Sorry for that. Okay, so now this is configuring and deploying. It is doing its health check. And if you see, it shows all other details. And this is the node pool which is being created, right? So now I also want to show you how we can connect to this cluster. We can use a Cloud Shell. Okay, so now our Cloud Shell is open. Now I can say connect to this cluster, and I can say run in Cloud Shell. Or I can also manually copy this guy. And paste it here. This will add this cluster 01 into my kubeconfig. Okay, now I can say kubectl get nodes. I think these two nodes are still under creation status. Okay, see, this one node which we created is ready. So this is how we can create a Kubernetes cluster manually, but that's not our intention. But then this is a choice. If anybody wants to quickly create any cluster, they can always come back here and do it. So let us delete this one. Okay, creation and deletion is done. Let us go to step 2, which is creation using GitLab's CI. Okay, so now I have this URL. Let us open this URL just for your reference. And this I made public, so anybody can come here and reuse this code. Okay, so now if you see, fundamentally I have only 2 files, simple GK and variable. Let us clone this. Okay, Terraform GK is simple. Now if you see, it only contains 2 files, nothing fancy here. Let us look at the files for a minute. Yeah, so now this folder contains only 2 files, simple GKE, and here I've defined provider as Google, and then I have made some of these configuration for the creation of this particular cluster, and then variable is the file which contains all the variables. Whatever I need here, the project name and credentials if I kept, and the cluster name. Okay, so now the cluster name is what I need to create. Let us say DevFestAB and Greg. Okay, I've made this file here. Cat variable.df, and here you'll see DevFestAB Greg. This is the cluster name. Now let us go back to the other commands here. So next is Terraform init. Okay. Terraform init. This initializes the requirement for the Terraform. Then Terraform plan. Okay. Now, if you go up and see, it will say what is that it's going to do. And Terraform is saying 2 to be added. One is the cluster and the other is the node pool. Then Terraform apply. Right, and I will say yes, and obviously, and then we will read this thing. Okay, I said Terraform apply yes, and then this is starting the creation of the cluster. So let us look, and then if you see in the top here, there is no cluster because I created manually from the console and I deleted it. Now it is creating, and what is it creating? If you read at the top, it will tell you more details. Okay, so now when I say Terraform apply, it is trying to create a cluster with all this detail. US Central 1, and the name is DevTestAB Greg in the default network. And let us look at the node pool details. And all other default values it is going to take. Like the machine type is E2-micro. Which is like small machine. I don't want to waste money here. And now the cluster creation is happening. Now, if we refresh here, maybe you'll start seeing that cluster. It will take a couple of minutes. Yay! DevFestAB Greg is being created. So this is what we defined. So now what anybody can do is, it is so simple. Just come to this repository and clone it to yourself. And then there's only 2 files. There's no complexity, nothing. The simple has got some of these the configurations you need to do here. There's no magic. It is very simple. And this is where we are defining the machine type and other detail. And it's not even like, long, like 20-page configuration. This script, if you take, and in the variable script, you can say like, what is your project name, right? What is your project name, and where is the location and the zone, and what is the cluster name. And if you have seen, I downloaded this and I ran this here, and it will take like less than 5 minutes to create. So this is a Terraform way of easily and manually creating it. And then if you come back and you can edit this file here, let us say you want the node count to be like 10. then you just need to come back here, then Terraform apply, then it will increase the node. So from this Terraform script, you can remotely manage your Kubernetes engine creation and making any configuration changes. You want to increase the number of nodes, all those Kubernetes cluster management tasks, you can do it from this simple Terraform script. You can change the configuration the way you want. Like instead of E2-micro, you can say high memory instances, any machine type you want, you can use it. And your node disk, you can change it. Instead of 10 GB disk, you want like a 100 GB disk, you can just add a 0 here and then apply, then you are good to go. So this is a from a command line Terraform way of doing it. The problem here is that you can only run it for, you have to git clone and you have to run it. But then if developer number 2 or any other DevOps engineer, or if somebody wants to make a change, then again they have to git pull and then do it and then git push, right? So this is the second way of doing it. Now let us go to the third way of doing it. That is from our GitLab CI. Okay, so now let us go to this URL. Parallel. Okay, this is still being created. Okay, so now I have a GitLab CI. This is a shared way or an automated way of building. So in this GitLab CI, what I've configured is I'm configured to create a Terraform container and then use the 3-stage like validate, plan, and apply 3-stage to deploy this Terraform script, right? So every time you commit, this is going to deploy automatically. And so let us look at this code and make a commit. Okay, and this I will close now because this job is done. That's my screen.
As you're getting that up, Jay, I'll just make a quick announcement. As you're getting that, just let it load in. And yeah, so everybody, just make sure you go to go.devfestab.com/win to enter for the prizes. Will be the prize drawing at 3:45, 3:45 or 4, so right in there. So yeah, just do that now. Jay, is it loading up?
Yeah. Yeah. Okay, so now if you look at these files, I've got all the configurations here. And here you can have your configurations. I'm going to share this also a bit later. All the same, whatever the Terraform script you saw, that I've coded here in this repository. Now, if we make any commits, it's going to deploy it. Okay, so now let us edit this file. And let us make a minor change. Here, let us say cluster name as 007, right? Just any name. So from a remote GitLab CI, I'm just going to make this change here, cluster name, and I'm going to commit it to master. Did I? Okay, let us check here. Yeah. So this job is running. Any new commit, like any change you make, this job will start running, and it will go to 2 steps. First is it will verify if everything is good and all those validation it is going to do. But the application is only manual, right? It's still doing validation and planning. We will come back to this in a minute. I just want to see what's happening to our other deployment. Okay, for whatever reason, I lost my shell here. Oh, it's here. Hey, apply complete. So this is the Terraform way of deploying your Kubernetes cluster is complete. And the magic is just 2 simple files, simple GKE and variable. And if you see, we went to this variable file and made this change Greg. Like I created a variable name DevFestAB Greg. And here we got our own Kubernetes cluster up and running, right? And if you see here, it took around 6 minutes, 6 minutes and like less than 7 minutes. So we have delivered on promise. In less than 7 minutes, just with 2 files, you can create it, and then you can change this file the way you want it, and then all those changes will be deployed, right? So now I also want to show you the destruction of this cluster which you have set up. And the reason why I'm destroying here is anyway we are going to create, we are in parallel creating another cluster. Okay, I'm saying yes. So here if you see, it's saying to destroy the cluster and the node pool in which all your compute is going to happen. So now after a few minutes you will see this will be deleted. Sorry, Greg. It has your name on it.
I felt like a constellation there, having a constellation named after me for just a few minutes, knowing that the universe that is named after me. So thank you, Jay. And of course, I'm glad to see you're tearing it down, though, because there's no point burning money.
Okay. But now we are in the third way of creating from a GitLab CI. And so now the validation planning is done. And here we named it as 007, which is another cluster name. And we are going to play here. And it will take 5 minutes-ish. And then here, if you see, I just want to show you how the display, how it runs and all. See, now this job is succeeded. Step 1. And this is the second job. The second part of this whole play, the planning phase. If you see, luckily, this also at the end said succeeded. So what it's going to say is, see, DevFest 007, it is going to add, and it is going to add this node also. So whatever from the command line you saw, all those details, it's all the same details. There's nothing much, nothing is changed. I've only taken those 2 simple scripts and made it to work on this GitLab CI. So this is the second part of the story. And the final part is here, all green. Okay, apply is currently happening. Okay, see now, still things are green. This is the same way it is going to create the cluster here. Now let us come back here and see what's happening. See now, this cluster is being created, being destroyed. Now, in few minutes, you will see DevFestAB 007 also coming here. Whenever our GitLab CI, so now what's happening is, okay, there is a CI default. Oh, there's already creating cluster. Okay, maybe it could be because I'm reusing the same network for this and that. So maybe it's not using it. So maybe we'll wait for the destruction of this, and then that should work, I believe. Okay, so let us wait for this cluster to be destroyed completely.
As we're waiting, Jay, yeah. Is it okay? We've got a couple of questions coming in from...
Please, that's a good idea. Yeah.
Yeah, absolutely. So what makes Kubernetes self-healing?
Okay, because, okay, now if you go to my presentation, what makes self-healing is because, let me show you the fundamental idea. Okay, now Google was running, Google created complex software to run their websites, such as the Google search, YouTube, Gmail, and dozens of other websites. So they had hundreds of engineers working for like 10 years on creating Borg and Omega, and their teams are called, like, SRE, site reliability engineer. So now with their immense load, they automated as much as possible over like 10 plus years. Then they learned like how to like build systems which never goes down. Like even if a particular node is down, like the load balancer sends the load to the other pods, for example. So all those things they have figured out over 10 years and built it internally, called Borg and Omega. And then they decided this idea of how to deploy with zero disruption, and even if how to have two copies of everything. All those ideas they had, and then they baked it into Kubernetes, and they made it free and open source, and they donated it to Cloud Native Computing Foundation, which is part of the Linux Foundation, the nonprofit Linux Foundation. So when Kubernetes was born, it came with the 10 years of or like 15 plus years of lesson learned of how to build the infrastructure, how to deploy the application. So all those self-healing capability, auto-scaling capability is inbuilt based on the lesson learned of running Google's infrastructure, right? So all these capabilities of self-healing is what Kubernetes is.
So it's not just one thing. It's a lot of things working in tandem to make sure that something can come back up and not have any downtime associated with it. I mean, essentially, a disruption happens, something fails out, or it just stops working. Instead of it getting past traffic, it's getting the new instance that's spinning up right next to it, because it's noticing that is the one that's now taking that traffic. So essentially, we're just moving the traffic around and making sure that it's always on a live resource. Is that right?
Correct. So even if this pod dies for whatever reason, like you have 50 other parts, or at least 5 other parts running. Yeah. Even if this whole of this node dies, a physical server or a virtual machine or a physical machine dies, you have these parts running here. This load balancer is what ensures that the load is sent to a live pod, right? Yeah. Parts can die, nodes can die, like anything can die, but the users will have access to the application because somewhere some pod is serving them. And then when there's more load, more pods, it adds, because this Kube API server knows like what is the current load, how many pods am I running, and every second this kubectl is monitoring itself and communicating to the Kube API server. And if this kubelet doesn't communicate this Kube API server that I am alive, then this Kube API server, or the brain of Kubernetes, they says, okay, this machine is dead. So now I should mark all these pods as dead, and I should only send all the loads to the other pods which is running in the other nodes. So all those intelligence, all those complex orchestration of running billions of pods, like 2 billion pods. Google was running, like even 5 years ago, 2 billion containers. Now that orchestration is what Kubernetes does for us.
Yeah, that makes sense. And of course it is, like you say, it's Google runs billions of containers, tears down tens of thousands of containers every hour. And I mean, if you, as everyone knows, you could leave your computer running for 6 years, right? If you never shut it off, then eventually it's just going to die out on you at a point in time when you don't want it to, right? And so if that's your only computer that you're running, but instead, so Google actually preemptively even kills containers off just to make sure that they come back and they work through their issues and they come back stronger.
Okay, let us run this pipeline again.
Yeah, let's take a look.
And here, if you see the existing cluster destruction is completed, and if you see there is no cluster for me, now we are going to start from scratch again. Run pipeline. I mean, we can make any commit, and then it will automatically run this pipeline also. Okay, so it is starting from scratch. And of these two repositories, the first one I made this already public, this simple GKE, and sorry, this one, the Terraform, this is public, but this I've not made it public, but soon I'm going to make public, because I want to ensure none of my keys or credentials are kept here. I'm going to delete it and then make it public so that anybody can fork it and they can look at the code. And if you're already using GitLab, then this is going to run as it is. But if you're using Circle CI or GitHub for your, or even any other tools for deployment, then you have to make changes accordingly so that it can run in that environment. Okay, now one last time I'm going to run. And if you look at this jobs here, this is like all the developers saying, look, it runs in my laptop or my desktop. I got it running like, today morning. You can see this apply has successfully passed here. But now my theory is that maybe because I ran it from the other way, it's trying to share the same. I coded the same lands, so I'm not sure. Let us see the last step. Okay, still running. If there's any questions, now is the time. And are we going to end this session? How many more minutes do we have, Greg?
Yeah, we have about 10 minutes, but I do have one more question just related to best practices. Best practices would then follow plan, validate, then run. Is that sort of how you describe it?
Yeah. Generally, otherwise, see, if you make it to run everything, then let us say whole thing takes 10 minutes to run. Mm-hmm. And then you have to wait for 10 minutes, even if there's a failure at step 1, right? So having multiple steps is convenient, and also even you can come back to GitLab and give access. Okay, if let us say it's a production environment, only a developer can run the test and plan state, and he or she is not allowed to push to production. So that somebody has to come, like a person of authority, like a manager or whoever is approved to do that. Maybe they should only come and click the button apply. So it is always good to have multiple levels and layers so that you can control by access, or you can go phase by phase. So it's a general principle people follow in a GitLab CI environment to have multiple phases.
Yeah, makes sense. Yeah, and it helps to segregate as well as you go through if you run into issues or.
Yeah, you will see where exactly it failed at least. And then next time when you run, you need not run it from the step 1. Like you can go to step 3 and click apply.
Yeah.
Thank you. Okay, this is still better. And yeah, so this is how generally the pipeline looks in a GitLab environment. Right, and you can click here, and you can see the steps or the phases which is configured here. First is validate and plan, and this apply. I've configured this apply not to be automatic, so that if there's any problem or error, I want to do it here. Otherwise, any developer comes and clicks commit, it will be in the Kubernetes cluster. I don't want that to happen. So I kept it apply because Generally, GitLab is used by a team of people. So if you have multiple people, at least this apply should not be given to everybody. But when it's commit, a validation and plan is okay. This apply can only should be given with. It should be preferably manual, or even you can add a approval. Like only a manager can click apply, and only specific time. All those configurations you can do. Okay, so far so good. Hey, Devfest 007 is being created here, right? So earlier we created DevFestAB, Greg. Now, if you remember, we changed and to 007 and we committed, and the cluster is being created successfully. I mean, it has created the cluster. Now the next step is the creation of the nodes. That's why it's taking some more time.
Jay, how long have you been working with Kubernetes for?
I mean, it was released 5 years ago, and then I saw it was at DockerCon, I believe. I saw that, I'm following this at least from the past 3 years, and I attended both of the KubeCons. And if you look at the community, there's a huge community we have for this KubeCon. Like last year, KubeCon was in San Diego. I was there, and it was very inspiring to see 12,000 people there, all stars of the creators of many components, and even people who created Kubernetes was there. And I'm mostly on and off working 3 years, and then past 20 years I've been working on Linux. Then I believe next 20 years Kubernetes is the way to go. So at the beginning of this year, I used to work as an architect for a large company based out of Calgary, headquartered in Toronto. Then I decided I need to work full-time on Kubernetes. I quit the job and then joined a small company as a DevOps engineer to work full-time only on Kubernetes. And I've decided I will only work on Kubernetes, nothing else, because I'm seeing this trend. The whole world will come to Kubernetes over time. Obviously, there is mainframe, there is Unix, there is virtual machines, all good. But I believe next 20 years, Kubernetes is the way to go. And I believe every single developer across the globe need to understand how to take his code and put it into a Docker container, and at least, leave it to the DevOps engineer or deploy himself or herself. So past 2 years on and off, but 2020, I'm full-time working only on Kubernetes, and there's no looking back.
Yeah, that's awesome. Yeah, I don't think there is any looking back. It's certainly, in a short period of time, has changed how we compute and how we manage resources and infrastructure, for sure. It's kind of insane, actually.
Okay, so this Kubernetes cluster is done. And any changes if you want to have any more deployments, you can do it from here. Yeah, so this is the cluster.
If it's going to take a second to pull up, I can introduce something. Just speak for a second, if you like.
Sorry.
If it takes a second to pull up, or if it's still pulling up, just let me know, and I've got someone I can fill the space with.
Sorry, I did not hear clearly. Just give me 1 minute. Let's do this.
Yeah,
hey, everything is green. Yay! Thanks to the demo god. Your 007 cluster is ready, which is done using 100% from the GitLab CI/CD tool. And if you come here, you will see the Kubernetes cluster, and this has created a 3-node okay, so let us look at the nodes. All the nodes are green. So just our GitLab CA is created. So anybody can use this and start learning. And only one last thing I want to show you is nothing will be complete without the kubectl command. Kubectl is the final entry to your cluster. I just want to run this kubectl command, and then we should be good to go. Copy, and this is Devfest 007. Paste. Okay. Kubectl get nodes. It shows my 3 nodes, and kubectl get the running pods. -- all namespaces. Hey, all running. Everything is running. Everything is good. So just to come back and conclude, you can set up your Kubernetes cluster manual way. And we also set Terraform, just 2 simple files from your command line, git clone, and it works. And you can go to GitLab CI, and then you can automate the whole of deployment. And it will help your whole team to come back and work. It's not that only one developer can do it. Any other developer can come back here, change code, and let us say you want to increase the number of nodes or any other configuration, or you want to upgrade, everything you can do from here. That's all from my side.
Awesome, Jay. Thanks a lot. I know how hard it is to do a live demo like that. And how
it worked at the end.
Yeah. Thanks to the demo gods for sure, and nice work on that. So thanks a lot for joining us today. Let me just check here. I don't think we had any more questions in chat for right now. So yeah, thanks a lot, Jay. Really appreciate you joining us, and yeah, we learned a lot from that. So
happy to hang out with you, Greg, and
awesome.
For the whole the community of all the DevFest team, and thanks for all the hard work you are doing in the background to share this knowledge and take it to everyone in spite of the constraints of COVID. Thanks a lot to you also, Greg.
You bet. Thanks so much. Yeah, thank you, and appreciate that. We wanted to mention now, just to call out the fact that we do, GCP has a free tier. So if you wanted to try out some of the things that you're learning about today, GCP's free tier includes free usage limit that doesn't expire. It's subject to change, of course, but ultimately there's actually quite a bit you can get done with GCP for free as a developer. To start with, you get $300 in free credits. So the place that you go to get that is cloud.google.com/free or go.devfestab.com/free. And you can get access to Cloud Run, like 2 million Cloud Run requests a month. You can get 1 gigabyte of Firestore storage. You can get an F1 micro instance per month on Compute Engine, a 5 gigabyte month standard storage on cloud storage, and there's 26 other things that you can get access to. And so if you are trying this stuff out, it does take a credit card just to validate that you're a real human being. But other than that, you can get up to $300 in free Google Cloud credit, which most people don't know about when they're new with GCP. So definitely take advantage of that, and you can get some really cool stuff built for free. So it's a good opportunity to get in on that. Our next speaker will be Karan Balkar. He's coming to us all the way from India, and we will have him starting at about 2:20. So we've got about a 10-minute intermission here to get everything turned back over. And we will see Karan Balkar in talking about integrating Google Assistant for continuous integration. It's a little bit of a shorter one, so only about 15 or 20 minutes. Then we'll hear from Padma, Polash, Paul out of Calgary here, and that'll take us to 3:45. at which point we will be doing our drawings. So make sure that you enter into the draw at go.devfestab.com/win. Again, that's go.devfestab.com/win. And make sure you get a chance to enter into our draw. We will announce what the prizes are there right before the draw as well, so you know what you're actually entering for. And yeah, other than that, we will see you in about 10 minutes. Thanks so much.
Clinging to my soul, I know I'm not alone in the shadows. In the shadows. Closing my eyes to find you standing in front of me, but this isn't a dream. Can you hear me now? I'm done with the games, I can't blame everybody else. I'm calling you out. I hear you in the night. It's when you come alive, screaming on the inside, you're inside. Oh, I feel you in my bones, clinging to my soul. I know I'm not alone in the shadows. In the shadows.
Shining on a cloudy day, and it don't matter what you say, 'cause even if the sky is falling, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here. There's nothing wrong on the horizon, but I'm always in my own head. Yeah, I was getting tired of trying, forgetting every word that I said in all those old conversations that turn into a melody. I'll be waiting for autumn days ahead of me. Those words that pulled me under are never coming back again. I like my beat with some soul, I like my girl with some heart. I only love with my whole, I don't know how to give part. I don't know how we gon' finish, but I love how we done start. So let's take a night to just be who we are. So I ain't got the time or the energy.
unless it's towards a goal or a memory. And to be doing things that I don't really love. Only light I had was coming from the sun. But now I'm shining on a cloudy day, and it don't matter what you say. Cause even if the sky is falling, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here.
Every day I got a light one, yeah. Never not that it a tight one, yeah. No, I keep it 100 every time I come in trouble. No, we coming with the right ones, yeah. 35 can't play, get a bag on ya. Never with the games, put a tag on ya. I ain't getting lit cause my future too bright. Joey hit me up, I said that's just on site. No, it's too nice. No ops, no lights, new heights that we never hit before, and I'm feeling too white. Gotta roll like a road on. Major difference is the platinum and the gold songs. Whoa, oh, you already know. I can make your life a push star, press go. Say we're off to a good start, let's smoke. Blew the brains off the coupe, baby, explode. Yeah.
Shining on a cloudy day, and it don't matter what you say. Cause even if the sky is falling, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here. Hey, let's move to back. Everybody come out here real quick. Everybody come out. Come here. We're gonna sing together. Hey.
Shining on a cloudy day, and it don't matter what you say. Cause even if the world is ending, I'ma do it anyway. So save your worries, slide your loving. I can feel that good things coming. Finally believe that it's gonna be a bright one here.
These days move slow, and smell like smoke. I know there are worse things than being alone.
Cause these days move slow, and I need some smoke. I know there are worse things than being alone.
But I'm far from home, and you seem so close. But my heart's still sore, and I know you're just feeling alone.
Cause I'm far from home, and you feel so close. And my heart's still sore, and with you I don't feel so alone.
You're tripping over every move I made tonight. So fall for me, and I'll catch you, baby. Cause these nights move fast, and I hope this lasts. We can let time pass, but you know that I'm gone and I can't look back.
These nights go fast, just hope this lasts. We can let time pass, but I know that you're gone and you're not coming back.
It's blue and black, with you it's bad. It's like you knew that I had to have you.
I'm bruised and black, with you I'm bad. It's like I knew that I can't, but I had to have you.
You're tripping over every move I made tonight.
Welcome back to DevFest Alberta. Glad to have you back after the short intermission. And of course, as you likely know, our Stream 2 has wrapped up. The Experts Lounge has wrapped up. So we just want to take a second to thank everybody who was part of Stream 2. We really did have an awesome time there, and I hope you all had a great opportunity to talk to some of our experts. So thanks to all of the experts that were on Stream 2. We're coming down to the home stretch right now. And we're really looking forward to finishing off strong. So right now we have Karan Balkar coming to us all the way from India, and we're really, really excited to spend some time today with you, Karan. Hi, how are you doing?
Hi, Greg. How are you? I'm fine. Thanks for having me.
Yeah, absolutely. I'm doing fine as well. I noticed in your profile there, you've got a picture of the Android statue at the Google headquarters. Do you want to tell me a little bit about that?
Yes, so this was last year in February. So I got an opportunity to visit the campus for a small event, and it was a great time. I got to meet a lot of fellow Googlers and learn a lot from them.
Yeah, absolutely. It's quite an experience. It's quite a different place overall, and with a different vibe for sure. So that's really cool. Yeah, and it's also really good to get a picture with the iconic Android statues and the all the different candy theme statues as well. So yeah, that's a good time. I'm glad you had a good time. Well, I'll let you take it away from here, and I'll pop back in about 15 minutes, and I'll just monitor the feed for questions, and we maybe have a few minutes for questions at the end. Sound good?
Yes, sounds good.
Awesome. Okay.
Okay, so good afternoon, everyone. So before I begin, a huge shout out to the DevFestAB and the GDGYYC team for putting up this event and inviting me here and giving me an opportunity to share my thoughts. Okay, so about me, I'll just briefly introduce myself. I am Karan Balkar, and I am born and brought up in Mumbai, India. I primarily work as a mobile developer, but more recently I've been exploring or dabbling with DevOps, DevSecOps, and AI. And apart from being passionate about technology, I'm also a self-published author for poetry. I love to travel to different places and, of course, meet new people as well. So that's about me. So my today's topic is basically about integrating Google Assistant for continuous integration. So let me begin by a quote by Albert Einstein, and he said that in the middle of every difficulty, there lies opportunity. And this is particularly evident in the world today. So as you might have, all of you might be aware that nowadays we are having more of virtual meetings, right? Work from home is something that most of us are doing. Social distancing has become the new buzzword, I would say. Home quarantine is something that most of us are also advised. And slowly and steadily, workspaces are slowly evolving to come to terms with this new normal. So before I come to the main topic, I would like to give you a brief background. As software developers or software professionals, I think there are certain concepts that I think many of us would be aware. And I'll briefly touch upon 3 of those concepts. The first concept is agile, and I know that agile is something that many of you might be aware. Like it's been there for like 2 decades now, and right from the time the Agile Manifesto was first defined. So why is agile so important, or why is agile development winning? I would say. So agile basically helps to provide better quality. So agile software projects are said to have a better efficiency and a better flexibility. They are also said to be more result oriented, where you actually need not have to wait till the very end to view the final product, where you can actually view parts of the product or parts of your software being developed in phases. So you not actually wait right till the end of the cycle. The next concept is something called as continuous integration. Is also something which I think is very much popular among all of us, all IT professionals. Continuous integration basically helps to put everything into one common place. So your code, your assets, your artifacts are all into one place. And why it is important is that it helps to basically integrate things at one common place. It helps to basically also make these results or integration results visible at one common place. And it also helps to apply the best software engineering practices to our project. So that is why continuous integration is also something which has been there and as everyone is aware. But what what particularly excites me is about this topic. So which is basically the third concept, which is voice first technologies. Now, I believe that, if you ask me what's the best way to solve a problem, I would say conversation. And voice first technologies are nothing but doing that. So if you ask me, like, how is voice first, beneficial, I would say voice first is something that is more natural, and it also helps to improve the accessibility. So, we all love data, right? I think data is something that we all want to know about. And data is basically simply a collection of facts. So here's a quick fact. So this is what Gartner has to say about, voice assistants. And this is the quote from Gartner. It says that 25% of digital workers will use virtual employee assistants daily by 2021. So this prediction is something that, one can actually look forward to in the near future. But as software professionals or developers, I'm sure most of us will come across a lot of problems these days, even despite all the technological advances being made currently. So what are these problems exactly? So I have listed down 4 problems that, as common as which are more common to developers or professionals, software professionals nowadays. So the first problem is about complexity. So our software projects are no longer, those simple projects where you have a simple front end and which connects to a back end, a single backend. So that's not no longer a case now. Right now, you have a single source which is connects to a client, basically which connects to multiple backends. So you have maybe an Oracle, an SAP. So the systems are no longer those simple systems. They are more and more complex, heterogeneous in nature. So that's why that's one of the pros I feel nowadays, and it's also becoming more complex day by day. The second problem is basically about large team sizes. So again, especially if you're working across multiple geographies, and in different time zones, sometimes it becomes difficult to manage things, and large team size can also be a bottleneck at some point of time. The third problem is about higher learning curve. So again, no longer does a person work only on a front end or on a back end these days. Like people expect you to know a bit of both right now. So there's always a higher learning curve that you as software developer has to basically know, or you are expected to learn new things, and all this basically has to be done against time. So time is something that is not in our hands, but it is something that we are always race against. So all these problems are basically, it involves we have to solve these problems in less time. So that is the biggest problem, I would say. So coming back to the main question, so why is information? I talked about data, and I mentioned the data is just a collection of facts. But if you ask me, we don't need data. What we need right now is information. So information is basically how we understand those facts in a particular context. So if you ask me in a DevOps kind of a scenario, what information would I need, or what information does everyone expect from me? So that would be something like how many test cases actually passed or failed, or when was the last build that you delivered, or what broke the last commit that I made. So these are some questions that as developers we need to answer, or we are expected to know the reason for that. So information is something that we need access to, and we need this information access from anywhere right now. So what are the challenges that one foresees? So because of these problems, and because of the information access everywhere kind of a scenario, what are some of the challenges that are existing right now? So the first challenge basically that I would like to highlight is about dependency and communication. So this is particularly evident in case of cross-functional teams. So when I say cross-functional, I think many of you might be aware, cross-functional, it basically involves people of different backgrounds. So maybe someone from a sales, someone from marketing, so different backgrounds. This is particularly evident in case of a software kind of a project team where you have a tester, you have a UI designer, you have a developer. And there is always some sort of dependency that exists between each one of them. For example, you would, as a developer, you would not be able to develop until you get approved UX designs from your UI designer. So that is something that you depend on him. Similarly, for a tester, you have to depend on once the developer basically finishes or implements that particular model in order to actually test it. So there's always some sort of dependency that exists. And communication again plays a very important role, because even the slightest of miscommunication can actually end up building the wrong product. And this basically is particularly becoming a challenge, especially in larger team sizes. So again, communication is one such area where I see a challenge right now. The second challenge is about time and cost metrics. So a lot of organizations actually spend a lot of time and effort basically in developing interactive web portals. Those kind of portals where you have interactive dashboards, with some CSS and everything to make it look beautiful and aesthetically presentable. But at the end of the day, these are just web portals which are there, but they are no longer or not maintained going forward. So, and a lot of time and effort is actually involved in developing these portals, which I feel is not required. The third and one of the most important challenge I feel is about zero manual intervention. Now we are in the age of automation, and no one actually likes to actually do things manually, right? So I think if I had to ask you to actually log in into a website and run a pipeline and do some configurations manually, I think you would not actually like it. But if I told you that there's a way of doing it automatically, I think that would be something that you would prefer. So zero manual intervention is something that has become a challenge, but there are ways to actually overcome it as well. And the fourth and the most important challenge is about organizational culture and methodology. So what does this mean actually? So every organization basically starts with a particular model. So let's say I started with a waterfall model, but actually ended up converting that waterfall into an agile. So this waterfall to agile transition doesn't happen overnight, and even if it does happen, it requires a lot of time and effort in terms of training your resources. So organizational culture and methodology changes can happen, but you need to understand how to overcome this challenge as well, because if not done properly, it can actually have an impact on the final product that is developed. So what is the solution to all this problem? So this is what I'm going to talk about today. So the solution involves basically creating a voice-based communication interface that uses natural human language, and that is basically leveraging the existing CI/CD framework. So in this case, say a Jenkins framework, and which exposes certain API to connect or to basically monitor the build status. So, and the third and the most important part of the solution is that it will leverage AI technology to basically communicate and create meaningful conversations. So I'll just jump to the architecture of this particular system. So basically you can see there will be an end user, an agent, which we can call, and there will be two building blocks over here. So one is basically an integration and a fulfillment. So an end user basically would say a particular expression, and that would basically be classified as an intent. So we have something called as intent matching. So let's say you say a particular expression like, give me the list of jobs. So that will be classified as a particular intent under the list of jobs category. And that will be connected to webhooks. So webhooks are basically nothing but service endpoints. And these service endpoints basically can be hooked up to any particular framework. So in this case, I have chosen Jenkins, but it can be extended to any other framework as well. So this is basically in a nutshell. So about how RESTful APIs can be leveraged here. So here, again, the services that you will develop can be hosted on a platform. So in this case, I have chosen Heroku, which is basically a platform as a service. So in any case, you can actually have this deployed anywhere, as long as it's connecting to the underlying framework. So what are the benefits of this solution? Again, it's basically extendable to other CI/CD platforms. It uses a voice-first approach. Again, it's natural, so you can use natural language to communicate with your agent. And most importantly, you can remotely monitor stuff. So that is the biggest advantage of this kind of a solution. I've also implemented this and posted a demo link. So feel free to have a look at it. I will also be sharing it in the live chat, so people can view the video as well. So to conclude, I think if you ask me what is the future of this kind of a solution, I would say it's good, because a large number of interfaces have been there for voice-first based interfaces, and as we speak, they are increasing day by day. Maybe in future we might see support more for wearable devices. So here it may be like smartwatches or smart glasses. Security and user verification is something that I agree would need to improve, but a lot of research has been going in this area. And at the end, the objective basically remains to improve the conversation. So that is basically the things that we would also be forcing in the near future. So that's about it from my side. I hope you you would take this and extend it. Maybe we can always get in touch if you have any queries. So this is my email ID, and if any questions, please feel free to get in touch, and I would be happy to share whatever the inputs I have with you. So thank you, everyone.
That's fantastic, Karan. Thank you for sharing all of that. I'm just checking in the stream, and how long do you think it would take to set this all up and get it going, like from your perspective?
Okay, so well, right now I have kind of implemented it using Jenkins, but what I'm trying to do right now is build a more generic platform where you can have service endpoints connected to any kind of framework. So in future, if suppose there's a new framework, new CI framework that comes in, you may not actually have to change anything. So that is what I'm trying to build on. But to answer your question, I think it should not take you like more than, I think, 30 minutes to get this up running. It's just some services that you need to deploy on your cloud solution. So, and that's it. And I think it should be all said and done. I think the dialog flow, the platform that I will be using, basically we need to configure some intents over there. And I think it should be good enough.
Darn, I wish we had another 15 minutes with you. We just set it up right now and get it running, but sadly we're out of time.
Okay.
Yeah, absolutely. And for anyone that's interested in asking Karan more questions, definitely reach out. I'm sure he'd love to hear from you.
Okay, sure. That's
yeah. Thank you so much for joining us today. And it is, I think, 2 o'clock or 3 o'clock in the morning where you are now. So thanks for staying up so late.
Well, thank you so much. And just one last thing, I think if you are passionate about something, then time is just a constant. So it is basically, I would love to participate in future as well. And it was really nice coming here. It's my first event, and hopefully I would be looking forward to many more such events in the future as well.
Awesome. We'd love to have you back. Thanks for joining us.
Thank you.
All right, everybody, we are moving on. We've got our last speaker, Padma Polash Paul from Calgary. You may or may not have heard of BrainToy. They are one of our, actually part of GDGYYC's startup group. And they've actually received credits from Google Cloud Platform as a startup. So we are really, really excited to hear a little bit more about MLOS, ML AutoML platform on GCP. So yeah, stick around for our last speaker. We'll get going at about 2:45-ish, and that'll run until about 3:45, at which point we will be doing our draw. So stick around. Thanks everybody for joining us.
Don't get jealous of the things I've done, 'cause I have made my way through the better days. I will not be angry if you walk away, 'cause it just proves that you are not okay. I should have known from the start that I was starting something. Ooh, ooh, ooh. I should have known right from the start that it would end. Stop your yelling, you used to be so calm. You were my number one. but now you're just no fun. I showed you my hand and you played it repeatedly. Oh, and now it's time to go back into me. Oh, I should've known from the start that I was doing something. Oh, I should've known right from the start that it would end in nothing. I can't help but feel the way I feel when I'm with you. When I'm with you, I can't help but feel the way I feel when I'm with you. When I'm with you.
To be honest, I don't have the words for this feeling. I feel alive every time we in my house just chilling. These butterflies come to life and my head starts spinning. And I crash every time that you say you're leaving. You know there's nothing I'd rather do than walk down the road and chill with you. Whenever I'm gone a while, I can't help but miss your smile and wish that I was back home. I wish that I was still home with you. You belong in my arms and I know you know it. Too far apart, yeah, we both get a little bit homesick. And I know you're in bed feeling worse than ever, because it just don't feel like home unless we're together. You know there's nothing I'd rather do than walk down the road and chill with you. Whenever I'm gone a while, I can't help but miss your smile and wish that I was back home. I wish that I was still home with you. That I was still home with you.
Small time boy caught in the big city, losing all my joy for a life that don't fit me. I got the same old dreams as a million fools, stacks of green and swimming pools. And I used to swear upon wisdom, you got brains to spare, you gotta give some. I side, psychotic guides to listen to their whines and maniacal cries. Worship the dollar and cent, why call it dissent? You holler and bent over the most tiny moderate dent in your mountains of gold. Accounts that you hold, you end up an old young blood man. That fountain is cold. And I used to swear upon wisdom. You got brains to spare, you gotta give some. I kick back a flare, my ignition. It's time to ride. When I need to feel alive, I just get in my car and drive. When life it starts to break my stride, I just get in my car and ride. What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? What you doing, what you doing, what you getting into? And when I need to feel alive, I just get in my car and drive. When life it starts to break my stride, I just get in my car and ride. Ooh, yeah, 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 yeah. I'm gonna drive my blues away. Yeah, yeah. Gonna drive my blues away. Just another sunny day.
Welcome back to DevFest Alberta, streaming live, of course, from my spare bedroom here in Calgary. And we're happy to be here with you today. We are in the home stretch. We are happy that you've stuck around. Thank you for taking the time today to visit with us. And hopefully you've learned something from all of this. We have a single speaker left. I'm really pleased to introduce Padma Polash Paul from BrainToy. And welcome, Padma.
Thank you.
Glad to have you here. Thanks for joining us.
Thank you. Hi.
Sure.
This is
I'll let you take over, and let's just get right into it. No worries at all.
Awesome. Thank you, Greg. So yeah, my name is Padma. So I'm with BrainToy. We're designing a MLOS machine learning platform that can actually handle end-to-end machine learning pipe, or like we called it MLOS. So we built the complete platform on Google Cloud. Like we have like several like steps throughout the process. I'll stay with this presentation very few minutes, and then I will move to the demo piece. So our platform is built into two pieces. One is MLOS, that is the main computation unit, and we also have ML cluster, that is where the deployment and orchestration, all this take place. So while we're talking about the MLOS, this is like it actually handles several user mode. Like someone can be very expert, we call it expert mode. Someone may want to just go through click, that can be a like visual mode. And we also have auto ML mode, so we're like uploading the data or connecting to the data sources and go through the process. I'll show you everything in the demo, but this is how the like architecture works, like completely built on like Google Compute Engine, Google Cloud DNS, and all other storage unit, and we call it node. This is highly scalable platform that can support up to millions or billions users at the same time, depending on the computational facility. So, and every node is actually the full deployed unit for a production machine learning. We can call it as a like a model factory. So, like thousands of models can be deployed. Thousands of models can talk to each other at the same place, same time, and like latency, like through the models are very less in our platform. So yeah, so during the demo, I'll talk about two main features. One is speed, and another is the control. So why we're talking about the speed and control? So speed is actually for someone who wants to do some like quick prototype and then want to deploy and see how that works and stuff like that. And control is where someone is very advanced who wants to like go with each and every step of model building and want to actually orchestrate each and every step. Let's say from the data processing to the model deployment or model governance piece, they want to go through a control basis, like want a full control over the model deployment. So, without wasting time, let's go to the demo. So if we go to console.mlos.io, this is where we can found our platform. So user can sign up or log in through Gmail. So let me log in here first. So I'm in my project. I created a project called DevFest 2020 AV. So when we're talking about the MLOS, this is the user interface for the our MLOS platform. So these desktop icons, the reason why we're saying this MLOS, this desktop icon can be like open, closed, minimized. We can process like a operating system. We are all familiar with Windows, Mac, or Linux operating system user interface. This is exactly built on like similar way. And when we're talking about the ML pipe, this ML pipe is actually where we put all these desktop icons in our platform. So data engine, where we handle all the data. I can connect to a data source. I can connect to a Google bucket, or I can upload my data, or I can have like SQL database or MongoDB database. We can bring it all the data to our data engine, and data engine will also handle data pre-processing, data wrangling, feature extraction process, training and validation set creation. And then we have ML workflow, where we all put AutoML and ML engine. In AutoML, we can just using the data with the target selection, it can go through the data pre-processing to the model building phase. ML engine is a visual ML where you can actually select your data, go step by step process. Then we have model governance in place. So once I created a model, that model can be governed and then maybe accepted or rejected by the third party or peer reviewed, and then it goes through a deployment process. We called it model deployer. So once model is deployed, it deployed as a microservice. That microservice is accessible through API key and access token from anywhere. And finally, the dashboard. This is like an utility dashboard. So it's like a model monitoring or model explainability for our platform. So you can actually go through the model, score new data set, check, swap, and deploy different models, see the model decay and all these things. So, and also the model uptime and stuff like that. Also create model statistics and share with others. So app can be shared with others. So let me go through the process. Maybe it will be easier for us to do that. So I'm in in my project, which is DevFest. I can just create a project here. I created several, but I'm in DevFest project. So I can just close those. I'll go through them. As I mentioned, like these are like OS kind of user interface. So let's go to data engine first. So in the data engine, I can upload data, or I can connect to GCS bucket. We also provide the S3 bucket connectivity. We have also some other connectivity, MongoDB and SQL platform and stuff like that. Now, in the raw data, what I'll do for this purpose, we also have a data store here where we just provided some example data set. This example data set, user can go there and then they can actually upload those data and go through their how this platform works and stuff like that. So there's some documentation is available there. All they can do, they just decide, I want to click on audit risk, fraud detection, or also I want to go with a language detection, like NLP space. Also want to go with the vision space, where I'll be able to we'll be able to actually show you how the same pipeline all works for both like vision, NLP, and tabular data. So if I go with the audit risk, let me close this. Just computing some statistics. And we can also go with the face recognition one. So just let me do those things also. And just in the background, I'm computing all the statistics and everything so that we'll be able to easily see those. Yeah, we're done with the computation. It's pretty fast. We're using really like 32 GB kind of Google Compute Engine, and like some 6 or 8 processor core for this cluster. So let me go to the data wrangling. So where we can see all the columns, these are open here. I can see the detailed statistics here for each of like data variables, like columns or features, whatever we call. And then we can also go with the feature analysis, like I can select multiple feature and analyze different statistics on those data. And there's also a wrangling piece where we can actually like wrangle our data. So before even we go to the machine learning, we want to process some of our data so that it's machine learning ready. Sometimes if my data is clean, I don't need that. But if my data is not clean, I want to just go and clean those data. Once that is done, then I can go directly to the machine learning. So the biggest thing that we're talking about so far, what we have seen is the visual ML. Like we can see, click, 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 go there, and then it works. But we also provide the controls to the users. So the control means like each and every step of the pipe. So if we're thinking that ML pipe, every step of this ML pipe, for example, wrangling, for example, feature extraction, maybe algorithm creation. Let's say I want to customize my TensorFlow, or I want to customize my scikit-learn algorithm, like machine learning algorithms, or I want to tweak my deployment code. Each and every step, we give them the control. So for the wrangling, though we put the control, let's say I can actually insert a code block. It's a micro code block that actually ingestible throughout the pipe. So the beauty of this platform is whenever you build a whole complete process, now you like what happened with the one-off model, when we want to build another model, we have to go to that model and then maybe modify the whole code. But this is a crazy development time and cost issue. But what we want, like I have a pipe that already built, I just want to ingest while I was cleaning my data, or I just want to ingest something that while I'm processing my like feature extraction space, or I want to inject something during the machine learning space. So that's where these are injectable. Once it is built, it's reusable also. For example, let's say I want to write a code that can be useful for replacing a value for a column, like replace column value, for example. I just created this code block, I saved it, and I can see my custom, like we provide lots of general purpose built-in wrangling processing steps, but we can also customize it. As soon as I create this, I can go to the edit in code editor and I can open up this one. So this is a code where all the variables are disclosed, all the variables and all the logics are disclosed here. And then we can actually write code and stuff like that. We can create actually complete package for data handling during the data wrangling process. So we can create new folders and put some new codes, upload my existing package, whatever I want. So what I did, this is just a single code. That's an example code is provided, for example. All we did, I can select, let's say, this column, for example, and I have these 754 values that are actually 0.2. I want to replace those points, just for example, 20012, something like that, just another precision, for example. It's like just an example operation. So once I got this, everything is processed. Now, as soon as I go there, and then so maybe I go there, and you see this has changed. So now this code block that what was created, it can be applied to any data set. It can be applied to anywhere. So it is a part of my recipe of the data pre-processing or data wrangling. So I can save these things as a recipe. Let's say dr devfest recipe 001 kind of things. I save it. Now later on, I may have new data incoming. I can just apply that recipe and work on that. Once I'm done with this, I can preview the data, what happened to my data, each and every steps. And finally, I can also save those data, another version. We keep the data what was the transformation happened through the data. So we keep track of each and every steps. So let's say new DB kind of things. I just saved it. So it saved a new data for me, but I can still go with this same data and do some other processing if I would like. Now, this is for tabular kind of data. Now, I can go again to my data engine and see what happened with the face recognition data. So what happened actually during the face recognition, for the face recognition data. So whenever we zip all these files, this is a face detection classification or face recognition problem. So we have 40 subjects. There's a 40 class classification problem, and for each subject we have 10 samples for each class. We zip the complete package into a folder, and we can zip it and upload here, and that will automatically identify what kind of classes and what kind of variables we have, like images we have. And also we can go there and actually open up those images one after another and see how those samples were working. For me, these are different phases. This is a very well-known public data set. Just for an example, we just put it there. So, but it can be any object detection, object classification kind of things. Once we have that model is that data is imported, that can be handled. Now, similar way, we can go for the natural language processing data, NLP data. So that can be, like, this is exactly the similar way we can say, sending what we did, maybe in one folder or several folders, we have different classes. We put all the documents. Let's say I want to classify emails, or I want to identify a project delay kind of things. So all the emails are put into different folders, and then the complete folder was zipped and then put here, so it can process all the data and give you a recommended class that you want to use. And then here we can also do several NLP kind of processing. We can see what are the data things, like what are the NLP data and kind of things. And we can do whatever we want to do for the wrangling place. Now, since we have all this data, so I just want to show you first the auto ML piece, and then I will also go with the manual ML. So for the auto ML, all I have to do, I need to select a data set, Let's say I select audit risk, for example. I just selected it. And I have a target variable, and I will name it as table. Let's say TBL, for example. I just say start autopilot. So all I did, I loaded the data. I just put the target variable and asked, okay, let's run the AutoML. So this is for tabular data in the same like workflow that we are following. So yeah, so there might be several algorithms that may not be applicable for maybe tabular data or stuff like that. Then it will notify us like what happened with one of these, and we can go for these different things, and then we can actually troubleshoot for each of these processing. Now I can go and select another data set. Let's say I can go select, let's say, face recognition data set. This is a like a vision problem. So I can go, or I can create a manual process, a manual model with that one. Let's say for here, we created a model and I can open it in our data engine, like from in our ML engine. Now I can go here and then maybe load another data set called language classification if it's for that. NLP data, or maybe I'll go with the manual process for some of this. One of the things that for the manual process, let's go with the data creation thing first. Let's say whenever we have all these raw data, we can have different wrangling steps and stuff like that. The first step will be define data set. So whenever we select this, let's say NLP data, I can select, okay, this is my input feature, and I have a target feature here. And maybe I want to do some like TF-IDF kind of processing. I have to select this data, and then I can say add to step. And I can just go through that. And it will also recommend you some of the like steps that are required, or MLOS is recommending you to do. So all I will do, I'll just select these inputs and directly go to the save as a data set. I save as a DBS kind of things. I just define the data set. Now I can go here and generate a data set. I can go for a split where I can actually have a 20/80 split or whatever split I want for machine learning. And you can see that with the AutoML piece, it's also generated the data set that was linked with the TBL tag. We just put a tag name over there, and it actually goes through a process from data creation, like a data set creation, cross-validation set creation to the model building. But we created just a data set because we're going through a visual ML space. So we have this data set. So the fact here is, no matter what kind of data I'm working on, it can be tabular data, it can be like vision data, or it can be NLP data. My data, like that, my processing of like going through the workflow or the pipe is the same. You'll feel exactly the same when you're processing the tabular data and the NLP or vision data. Like once the data set is created, I can directly go to a ML engine. So in the ML engine, I can create a container. Let's say when I select the data set. I may have 20 different data set for my test set. I said NLP model 01, for example. I selected this data set. Now we have a range of like visual code, like a visual ML algorithm selection. So we have nearest neighbor classifier and all these things. Also, we have TensorFlow for we have fast text, we have PyTorch, like several things for vision, and also like tabular data or NLP data. I'll just select one of these. Let's say random first. I want to go with that one, and then I'll just create a model there. So it may take some time and then create a model with the accuracy of 97%. And you can see the rock curve there, and then what is the accuracy. But here I may say, okay, I have a data set that I was using and I have selected one classifier. I don't want to go with all these all this selection and stuff like that, and changing the parameters and stuff like that. So what I say, I want to sit back and say, let's go with the autopilot. So what it will do for me, it will create a autopilot like mode, like it will try almost all the algorithms. This is like an access for the like the visual ML users, access to the auto ML feature. So this is also included here. So we can have several like different algorithms that can actually go through different testing and stuff like that to create. Now we created a NLP model. We created a tabular model. Now let's create a vision model, like computer vision model. So what I'll do, I'll go again to that my data set. So I have a face recognition data. I'll say, okay, this is my image data, and this is my recommended class. And I'll go here, and then I'll say, okay, I want to work on grayscale image, let's say. Some of this recommended, add to step. And I want to convert to, let's say I want to use, let's say PCA with, let's say, 25 components for my algorithm. And I just create a data set for face recognition. And then I just say data set saved. Here I go here, I can create a split like that and then generate the data set. So what the flow is exactly like the way the tabular data was handled, the way the NLP data was handled is exactly the same. Now when we see those training and test set, I can see that different classes are created, different variables were created here. Now I can go to the ML engine again, and I can create another container with this, and then I can say, okay, vision face recognition, for example, and I selected it, and I can use any algorithms I want. I don't want to go with the deep learning. It might take a long time. I don't want to wait for this process. I just want to go with the first one, and we can also configure the GPU and stuff like that in the MLOS. So I'll just go any of them. I just default something and then create. So once I create, it will automatically do all this processing and then prepare the data set, and I can see, okay, I got a 92% accuracy for something, and it's not a good model anyway. But again, I can go with the autopilot mode, or which is a connection between the auto ML mode also here. So this is the pipe that is created for both NLP, vision, and tabular data, also for time series data. So multivariate time series are like a tabular, you can process like a tabular data, but then during the wrangling phase that I didn't show here, for example, if I go with the audit risk data, for example, now I have, let's say, in univariate data set, I may have just a single column, which is the time of, let's say I want to predict weather tomorrow, what would be my temperature? So I have a column of temperature for last 200 days, for example, and I want to use that to predict what would be the tomorrow's temperature or what would be the next month temperature. So all we can do, we can select a variable, maybe, and we can say, okay, processes as a univariate processing, and then all we can do, let's try something. Let's say I want to take last 20 days, for example. I say, okay, last 20 days, and I want to predict 2 days ahead or 3 days ahead or 5 days ahead. And let's take a 5 days ahead kind of things. And I can add to step and just apply. Hopefully, even though this is not a time series data set, I can still process it. This is something, but you can see. So you think that we have the assumption is we may have just a single column. What we did, we took last 5 days, which was T0, T1, T2, T3, and T5, and we have target date, which is 20 days ahead. So based on last 5 days data, now it has a data set. All I can do, I can just preview this data set also. You can see that how the target were created. And this is a univariate time series data set, and I can just save it as, let's say, my new TS data, for example. Then I just put it there. So it will save. Once it's saved, everything is in my, everything should be in the raw data, my data, which is my data, raw data. All the data comes in MLOS. So everything stacked here so that it's easily accessible. And I can go with this analysis again, do some processing if I would like, or I can go to like a model building. Time series is also built like a same pipe. Now I can go to ML engine and I can create another container. Oh, sorry, I didn't create actually data set. Sorry to do that. What I have to do, now I have this new data set from the data engine, which is my new this data set. So I'll just select this is target because we created this, it knows the target. And then there's no step required because everything looks numbers. I just say DVS time series DS, something like that. I define this. And again, with the time operation, it goes, okay, from the very beginning to the end. We assume that it's a sorted time series. But if it's not sorted, there's a way of doing that also. I don't want to go in details, but let's generate a data set. So I just generated. So you can see there's like 80% or 20 split with the target. And I want to see, this is actually a regression program. So what I will do actually, I'll go to the machine learning engine and I'll go to the regression. So what I will do, I'll select this new same data and time series data set. I say TS data set, for example. Something, TS model, time series model, for example. It can be well production prediction model, or a virtual meter can be. It can be a well virtual meter when the test separator is not active, but you have a production going on, but you want to predict what would be the test separator values without even running the test separator kind of things. So again, I have a list of regression algorithms. I can use any of them, whatever it is, but I can go with AutoML or something. Let's say I select random first again, and I can show you, let's create a model. So this is a regression model from univariate time series that we are creating. And we got a like a performance with the MSC and MEE, those pretty small, which is okay. And I can again run autopilot. I don't know which one will give me the best result. It's another form of autopilot from the ML engine instead of going directly through the AutoML itself. So we have pretty good response here. We get 0.007% accuracy for all this model, all this algorithms that we're using. So this is the model building process. So I know I have gone through several steps, but what we have shown so far, how to process the time series data, how to process the tabular data, how to process NLP data, how to process vision data with the same pipe. So we have the same pipe. I don't need to think about, okay, what should I do with NLP? What should I have to bring all these things, but everything is the same pipe, same way it goes, you create the model. But model building, maybe there's the most easy part so far, but what happened next? Let's try something. I'll take for the deployment, I'll take this model, for example, and I may have different models here. I can compare, contrast. I can see which model was good for me in terms of time and space, which one was good in terms of the parameters. XGBoost takes lots of parameters anyway, so, but we have several things here. But I wanna go through a like peer review for this model before I go to the deployment. So most of our clients, like some of our clients, they have, let's say they have engineering team, they have their development team. So development team, they build the models and everything, and they go through a like review process for that model. And then when the model is reviewed and everything accepted and then tested, bias was checked and everything, then it transferred to the production environment or stuff like that. And then, so this process, like they can just publish a model. Now, when I publish a model, what I will do, I'll just publish to myself. Let's say I'll publish to myself because I want to be the reviewer and for the demo purpose. I just publish some of those models. Now, one thing here, each and every model has its configuration for the developer, how those models were, like how the data was processed here, how the algorithms were parameter tuned, or how the model was created with the documentation and everything. So this is the documentation that's created for the developer. It's the most hard part for the data scientists or developers to document these things, but MLOS document everything just like automatically. So it goes through several feature importance, how the test and training sets were like separated, distribution, how the performance was. They can also upload some documents during the review process for the communication purpose. But once this model is published, they can go to the fourth step or third step, which is actually the model governance. So what happened, I can see this model, how that was created and everything that is for the reviewer. I selected myself as a reviewer, so I can see this model. Now I can also see is like if this accepted or I can accept or reject. So it sends email that, okay, this model was accepted or rejected. Let's accept some of those models because I want to show you how the model swapping works. Because today I may create a model in 1 month, or tomorrow I need to get a new data, train new things, and deploy it to the production. So that my all the applications that is connected to that microservice, they can actually get updated model versions result. So I accepted several models here. Once accepted, document like what I can go to the model deployment, which is the fourth step in our ML pipe. So let's say I have already several application running. So what happened? This was this is running for another app. So what I will do, I'll just go select swap model. I select this TBL audit risk for ML. So I'll select one of the model version that I would like. I just select and confirm, and then I click deploy. When I see deploy, and it's in ML cluster. So when I'm seeing ML cluster, this is actually updated version, or it's a modified version of the Docker. The reason why I'm saying that modified version of the Docker, because we also have the Docker version that you can also deploy into Docker. But when a ML cluster and MLOS cluster is running together in GCS, what happened? Maybe multiple or 10, 20, 15 compute engine are connected with each other, and they're talking to each other. And then each of these compute engine are creating a cluster for deployment. They can be deployed through a Docker, or it can be directly deployed, or it can deploy in an ML cluster. The beauty about ML cluster is actually the fast deployment. Fast deployment, it takes just 40 seconds for deployment. But maybe in the Docker, it takes more time to deploy, and it gets everything from the maybe the private or like public repository or stuff like that. And then yeah, so we actually modified or reorchestrated our ML cluster. So once it's there, so it just with the like you can see, so it is deployed. So it's starting the application. It may take just a second to start. Now it's running. Now we can also see different logs here. What happened? If there are any error or something, or maybe the like some error, or if there is some output or console output we want to see, this can be there. We can also see the code here, what was used to deploy this model, and it is open as an API endpoint. So once model is deployed, it actually now is a live API for every one. So let's say this is the API endpoint. What happens? So now let's say it's like maybe it's still running. Let me double check. Let me go to, yes, it's running now. Yes. So what I can do, I can go API and go say, okay, do a post request. It will give us what is the training set, what should be the input parameter for me, and stuff like that. It will also give me a sample post. So what should be my sample look like, and how should I post for this API endpoint? Or I can see how the predict will work. So for example, if I take some of this data and I put in the payload of this API endpoint, and I can say just post it, and then it will give me a response from that API endpoint. So this is the API access. It's like you can also try it from the Postman, but so that you don't need to go anywhere else. So we just created this here for 3 of these model endpoint. And so also one thing I also want to show, like app history. So this may have, like, this is just a new app we deployed. So this may have gone through, let's say, 20 different revision. Let's say we deployed, switch 20 different models. So we're gonna go through that like process. We're gonna see all these things. Now, once this app is deployed, we have a utility dashboard. So once we have utility dashboard, so what we can do, actually, let me hide the notification. So all this utility dashboard can do is we can just go for a prediction, like we can change some of this data and try to see, okay, what would be my response for that, and see, okay, what was the API response time for my API. Let's say with the GCP, it's very nice to have like very small latency, like it's 37 milliseconds. It's very fast. So that was the, like, we're using in terms of the infrastructure for our platform, we're using pretty like high IOPS and stuff like that. And we can also score different data set. Like I can go and score. These are all actually equipment for the visual ML, and also with the control feature, some of the places where you can insert code and update some of this code. And this is actually the validation set, or some of the model version was used to predict. Now this has gone through a deployment, and then this model is actually live. So, but how to access this from outside? So what I can do actually, before when I go to algorithm manager and stuff, like I will show you more stuff there, but I want to show you this small simple test, just a test app. So what will happen? This actually creates a test app for you. Like I can say predict, but access token and stuff like that. So all we have to do, if I go to the source code, so all I need to do is, so I have to just change the API key and access token for this. As soon as I have API key and access token, then it will automatically call that like app that is deployed. So what I'll do, I'll just now go and create an API key or access token. So how I can go there? I can right click, go to add an app, or I can go here. There's a lots of utility here, and I can go to app manager. As soon as I go to app manager, I can share this app with my users, or I can create API key and stuff like this. So I have an API key. So what I can do, these are very, I can delete and stuff like that. You can see that, but it's okay. I can delete those things. So what I can do actually, so I'm going to go to that last configuration, which is maybe the test. Yes. So I'll open it in a user code. I think you can see that. So all I will do, I'll just go here, paste it here, and I'll take this API key access token, I place it there, I save it. If I go here, and when I save it, let's try to predict. And I can see the predicted result. And now I can actually go through any change, whatever, I can predict those things. So this is just an example for the developer, how they can actually integrate these things to some other place. Now, this is how the app manager works, and this is accessible from anywhere. Now let's go to more advanced feature and more control feature that can be used for, let's say, advanced developer. Let's say whatever algorithm we have provided here, let's say I'm not satisfied with these algorithms. I need more advanced algorithm. I don't want to use anything. I want to create some custom algorithm. Now, way of creating custom algorithms, all I can do, I go here in the algorithm manager, where I may have several classification and regression algorithms. And I can share those algorithms with my team members so that they can also utilize those algorithms to create something. So let's say if I create something new, first I'll go to one, for example. I create a new one. I can go here and edit in a a code editor. Now this is like sample code we provided. User can go and do whatever package they want, whatever system they want, they can utilize those things and then write those code. And the way they apply this algorithm, as soon as they update those algorithms, what they can do, they can come here, select this, and then select the Devfest algorithm. This is an example, so all these codes and everything, parameters, how it is configured is there. Select this and just compute a new version. And then it will be like it is just applied on that algorithm, Devfest algorithm. So that was used, and what are the parameters that we're using, and accuracy is pretty good, but yeah, it's 100%. So there's no false positive or false negative. So that's why it's the curve is like the curve is going down. Now, this is the algorithm that we created using our algorithm manager, and then we can modify, like update whatever we want, and we can actually bring it to the ML pipe. Now it goes directly to the deployment. So the same model that I was using before, now with the modified algorithm, I can build that model again and then take it to my deployed version. So that means that it'll be in the production already. Like this process can take literally, maybe depending on the model computation time, it may like take literally 5 minutes from a like model creation to the deploying the model, and it's in the production. So this is how this algorithm manager works. Now, so there are some other application, like we call it application. The reason why, like it's like a it's completely a waste kind of architecture, like user interface also, where you can actually go with the main menu and main application you have. I can go to the utilities when I can see how many users I may have, or if it's running in my organization, or I may go to my how many apps I'm running, or I may go to my storage, how much storage I'm using, stuff like that. So it may take some calculation time, but I may also go and see, okay, how many packages are installed in my MLOS. So for example, I may have different packages. I want to install new packages in Python packages in my MLOS. So I can just type a package name and it will install for me. I can go, okay, how many MLOS I have? I may have 20 different cluster of MLOS running. So this is, I have just one MLOS. This is, which is in this one, because this is our public instance where user can go and log in there and then try our MLOS. And like if for the enterprise users, when they have everything in their cloud, they can actually add multiple MLOS and ML cluster for their deployment and stuff like that, and they'll be able to see all these cluster one after another here. So it's like different sets of compute engine, drives, and then network storage, and with the cloud DNS and everything, it goes there and it creates a complete environment that actually do it there. It's just a click of a button that can create the whole process. Also, it includes all this help, how can also API references for the developers, how they can actually connect to those APIs using different programming languages, different kind of API predict kind of things. And there's some tutorials available for all these, what is it called? Like all these different data set is coming along. Like maybe we will have 100, 200 data in the data store near future. And also we have for the easy of useness, so they can actually go through each and every window, how they can actually proceed with the process. So they don't need to actually be very proficient with it. So the reason why we created this way, we covered actually, so we want to simplify the ML building process through ML. So we want to simplify different stages for the user level, also in the usage level. Let's say I may have a very expert user who are like expert data scientists in my organization. I want them to be very productive, and they might want to use this to build more thing and stuff like that. This is one level of user like access. It can be very domain knowledge based people who have domain knowledge. They want to take their domain knowledge and click go through, they can build their model. So we want to cover several level of users, several level of process of building machine learning model. That's why we built auto ML, visual ML, and expert ML. So depending on the different user, they can do that. I think that's all for my presentation. And let's see if you have any question. So I just want to go to the presentation link. So speed and control, console.mls.io if you want to try there. And yeah, so we want to build in a revolutionary price, and you can reach me at ppong@braintoy.ai. And this is our founding members for BrainToy. Yeah, thank you.
Yeah, Padma, thank you for that. That was awesome. It's clear that you guys have come a long way. I mean, I remember talking to the team there about a year and a half ago when they first were trying to get things going and off the ground. And quick question for you. I mean, I know that you guys have been using the Google for Startups credits. How has that been helpful for you, and what has it done for you?
Oh my God, that is the best thing. And this is the maybe like awesome thing happened for our startup, so that we can actually use that credit to go to that level actually. Because when we have a development environment, but still the way the everything works, like we're actually using most of our development environment also in Google Cloud. Like it's not a on-prem development environment. It's actually onto the Google. Like we're creating maybe one compute engine and deleting every day. Maybe we're creating 200 compute engine and deleting 200 compute engines at the same time. Like, and every time, and maybe you are running for, let's say, 3-4 months, and you are actually trying GPU basic instances. Those are very costly instances, right? In some places. So that Google credit was like a real lifesaver for us.
Yeah, it's good to hear. I'm glad to hear it. It's yeah, I'm glad, and that's exactly what it's for. It's just to help startups get off the ground and build something that, that in your case, that other developers will use, which is even better, right? It's not just a casual user or otherwise. So, I'm really happy that helped out. Yeah, so I'm seeing that we don't have a lot of unanswered questions, and yeah, I think, let's see here. Can the data wrangling process take log files, for example, from multiple systems? Is the question.
Sorry, again, what was the question? Multiple, what kind of file?
Can it process log files, for example, from multiple systems?
Oh, yeah. Any file, like if you have like hundreds of thousands of log file, all you do, you just dump into a folder, zip it, and upload it, and it will process for you.
Cool. Okay, that's good to know. Yeah, and that's sort of the questions that we had right now. So, yeah, thanks everybody. It was yeah, really appreciate you joining us today, Padma, and sharing so much. One quick thing is maybe we should ask do you have a free trial for your stuff, and if so, what is the address for that?
Okay, so if we go to BrainToy.ai, BrainToy.ai, there's a free trial. Let me go there. BrainToy.ai. As soon as we go there, there's a free trial.
Okay.
And as soon as we go click on this free trial, and then it will just click on sign in. That will move you to console.mls.io. That's it.
Perfect. So if anyone's looking to try it out, there is a free trial, and
absolutely.
And I'm sure that the BrainToy team would be happy to show you around if needed.
Yeah, please reach out to any one of us. I just put my email address here. We're happy to show you the demo. We're happy to show you, handhold you how to develop a model. We try to put most of the help files there to our best, but still we're always open to be with you and sit with you to solve a use case. And normally with our customer, it takes like 20 minutes, maybe in some cases, to solve a use case and put it in production.
Oh, that's awesome. Yeah, that definitely brings down the load, the burden for sure. Well, thanks so much, Padma, and congratulations to you and your team successfully launching in October. That's really exciting.
Thank you so much.
Thank you. So,
thank you.
Yeah, thanks for coming. So we're going to move now to the final little segment of the day today. We have prizes coming up at 3:45. And so we're just going to take a minute or two and get ready for that. You should see us pop back in here in a few minutes, but you'll see a countdown on your screen starting right about now-ish. So thanks for joining us today, and we'll come back for prizes.
Try to ride on the high of the days unknown. Memories filling me with the trace of all unknown. When everything's impaired and no one seems to care, I know I cannot rise above. 'Cause I'm alone, just looking for love inside this dark I roam. With all these shadows that I've known, I need a place to run. But I'm alone, just looking for love. But I'm alone, just looking for love, looking for love. But I'm alone, just looking for love.
love you better, 'cause you're all I know, oh, you're all I need. But it's complicated, I'm my own safe haven, and it's not the way you believe. And I'm stuck in between what I know and what I feel. Why are we so unsteady, baby? Tell me. And you see right through me, but you still know what I need. Why are we so unsteady? Tell me. Like a single flame, baby, light the way. We don't need to think about who to blame. It's just so complicated. Promises keep breaking, and I hate that you are all I need. And I'm stuck in between what I know and what I feel. Why are we so unsteady, baby? Tell me.
Welcome to the last small segment of DevFest Alberta, DevFestAB. Thank you for sticking with us all day. It has been an awesome but a long day, and we're happy to have you back. So yeah, it is time now. And just before we start the prizes, I just want to say a couple of things. And the first thing that I want to say is thank you to all of you who have joined. We couldn't have done this without you, and certainly having you here and your energy has been fantastic. The second thing is I also want to say something like this does not come off without a lot of work by a lot of people. And that includes Rebecca, Renato, Mike, Kylie, Surya Tapa, a number of people from the Google developer group, Cloud Edmonton. Will and his team have been absolutely fantastic. Carrie and Vanessa and the moderators in Stream 2. So thank you so much for that. We also want to thank the Google developer groups for supporting us in this. And yeah, again, just thanks to everybody for being here and for being part of it.
I think there's probably one person that you might be missing, Greg. And yeah, I actually came on camera for this one. I'm not just the voice in your head. I want to make sure that we give a huge, huge shout out to Greg Bennett, who is the founder of GDGYYC and who pulls this together no matter how he's feeling, no matter what else is going on in his life or in the world. And yeah, we couldn't do it without you. Renato, you're an absolute technical genius. Thanks for everything you did for all of us today. And okay, now I'll disappear again and just be the voice in your head. But thank you, Greg.
Absolutely. Thanks so much, Rebecca. I appreciate that. That means a lot. So yes, thank you to everybody. So let's do a couple of prizes. The first one is a $25 Google Play gift card. I'm just going to quickly check that we have everyone's name in here. So we're going to close it as of right now. And then, yeah, just give me 1 second. I'll just get this in and set up. We had one more person pop in there while I was talking. And just give me 1/4 second here. And yes, so all paste. And we are going to switch the focus from, stop that, and then reshare. So we're going to go to the wheel of names. So the first prize is for a $25 gift card to the Google Play Store. We figured that it would be easy enough for you to spend that money and we wouldn't have to track you down and hand it to you in an envelope that we've licked with our lips. So we'll forego that and we'll just send it to you and get it sorted out that way. So here it is, Wheel of Names. For those of you who don't know, Wheel of Names was actually developed by Martin Omander, who spoke this morning. So we use this tool a lot. It's just wheelofnames.com. And but yeah, we're really lucky to have had Martin speak this morning. And so yeah, let's get going. We'll just do the little spin. I don't think the sound is going to come through just because we do kill off the sound in this feed, but let's give it a whirl. And oh, we've got Michelle L. Congratulations, Michelle. We'll reach out to you. We'll reach out to you to make sure that we get that gift card to you. One quick second. I'm just going to check that we have only one Michelle in here so that we don't have a problem finding you. Oh, let's see, Michelle L. Okay, I assume that's Michelle L at Michelle Alberta. Let me just double check here. Yes, and that is you. So Michelle L. Congratulations. We'll reach out via email. We do have your email address. Okay, so let's remove Michelle. The second prize is another $25 gift card to the Google Play Store, and we will just go after it. So let's see who wins this one. Awesome. And Bam Bam W. Perfect. So congratulations, Bam Bam and Michelle. That is those are the two Google Play gift cards. And we've got one more prize here, which will be, I think I'm sharing my screen, but 1 second here while I do this. And yeah, we'll just switch back for a second so we can talk about the prize. And basically what it is interesting. Well, give me 1 second here. Will be, oh, there it is. I think this is it. And that's the posting camera. Okay, speaker slides. Okay, let's just see here. My brain is fried, I will say that. And oh, I am. Okay, we'll stick with Wheel of Names. But anyways, the prize is a Google, as you know, it's a Google Nest Hub. And so that's the one with the screen on it that you can put on your counter. I use my Google Nest Hub all the time for when you're cooking. You notice we had some cooking themed stuff here at lunchtime, but really great to be able to let Google know that you just need to start a timer, see when those timers are, or even pull up a recipe. So the Google Nest Hub will be the final prize of the day. And yeah, so everyone cross your fingers, cross your legs, and we'll get going. All right. It looks like that is going to Khaled A. So we will reach out to all of you and get that sorted out in terms of prizes. So thank you everybody for coming and joining and participating. We really, really appreciate everything that you've done, and we look forward to seeing you at a future event.
Thought I would never say it would have ended like this. So we went down a limb, now we're standing in the middle of a mess. Go on and tell your friends, but me and my friends weren't good enough, weren't good enough. Go on and tell your friends, but me and my friends weren't good enough, weren't good enough, weren't good enough. Oh, 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 I never wanted this turn. Oh, oh,
Oh, that's true. Bam, 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 bam. Bam, bam. Michelle Lee. Oh, Bam, Bam W and Michelle Lee. Michelle's so funny. Michelle Lee.
Drawn to rolling, me and my friends over now this did all night, yeah. Been dreaming big since '99. Guess you're on the right, coming for a ride.